Madhya Pradesh. So maybe Dr. Mahapatra can, take it up from the NCBM side, that WHRS must be recognized as green power for what it is. Now, you'll be all discussing how many million tons of CO2 that are released in the air. Now, when you make cement, you have calcium carbide, limestone, which is CaCO3, and you heat it to 1500 degrees temperature. So it releases carbon dioxide because you need calcium from the process to make cement. In the process, we need only calcium. So CO2 is being released in the atmosphere, and calcium oxide we are then converting into clinker and then to cement, which is calcium silicate hydrate gel, CSH. Now this CO2 is a part of calcium carbonate which has to be released, otherwise you do not get calcium oxide. So that's one part where CO2 is coming in the atmosphere. Second is when you burn coal and you burn pet coke or you burn lignite. So that is again another area. And the third is electricity that you are using to burn, to run your machines and light the power and all this. So all heavy industries, whether it is aluminium or it is steel or it is cement or anywhere where you are using natural resources in the production process, so they all release CO2 in some form or the other. So the biggest challenge is that as we go for development, CO2 is going to be released. We have to capture it back. So at Prism Cement, we plant 1.5 lakh trees every year. We have already in the last 4 years planted 6 lakh trees, of which more than 5 lakh are surviving. And we have run out of space inside the plant. It's all forested. Dr. Mahapatra has come to our plant and seen our colonies are forests, our mines are forests. We keep planting trees. And now we have taken up social forestry. We have applied to the government of Madhya Pradesh that wherever you have barren land and you need forestry, we will, because our target is 1.5 lakh trees every year plantation. So this year we have been granted some forest blocks where we will be extending it. And but it is simply not sufficient. You need to do more. So we are also working on carbon capture technologies. You must have heard that one cement plant, Heidelberg, overseas has been given a grant by the UK government, and carbon capture technology plant has already been put up, and it's the first in the world, and we are also observing what is required to be done in that. So we will also be moving. Many cement plants in India have already declared their intention to be zero carbon net producer by 2050. We have also, in line with what the Prime Minister has said, till 2070, India will be a net CO2 emitter. So we are also looking at whatever CO2 for development is required, you have to pull it back, and we are working on that. Another area that we are working very extensively, which Dr. Mahapatra must have seen in his last visit, is raising the water table in the ground. So you'll be very glad to know that we have raised the water table around Prism Cement Factory for roughly 40 square kilometers around us by 2 meters in the ground level. So whatever water is being pulled out from the ground by the community, including farmers and everybody else, we are putting in such that every year the water table should come up. And when we started this exercise 4 years back, we were in a critical zone. We have already brought it to a semi-safe zone. And this year the monsoon is a little less. Normal monsoon, sorry, my alarms are ringing to leave. So I'll leave after the speech if you don't mind. So we have been looking at how much water is taken out by the community, not just the cement plant. And our target is to raise the water table up. So that's another area that one day we can, my people can come and speak to you how it can be done. We've calculated the cost. We've calculated how much money, effort is required to raise the water table by 1 meter. And we are spending that kind of money. And our target is that from 16, 17 meters water table in that area to bring it to 6 meters going forward, which is pre-industrialization period. before industrialization, water table around the country used to be barely 543 meters. You dig and you used to find water. And today you go up to 300 feet and you don't get water. So that's another area along with CO2 that we are working on. So thanks a lot. It has been a pleasure to have come here. And I will come again, sir. I will spend more time with you after that, having seen the beautiful facilities and the kind of nation building that you are doing. And it is always a pride to me when I meet young, bright, when we recruit management trainees. It's always a pleasure to me when we recruit. And recently one girl said her father is a rickshaw driver. Actually a rickshaw driver, and she's an engineer. Another girl who we have recruited in the management trainee batch, her father is an auto rickshaw driver. Another boy we recruited, he doesn't have a father. He's brought up by his mother in a retail outlet. किराने की दुकान चला के उन्होंने उसको बड़ा किया है. So it's a pleasure to see how India is transforming, and it's institutes like yours which are making this happen. Thank you.
Thank you, sir. Thank you, sir, for giving such a valuable knowledge to our students. And definitely, as we know, carbon emission is one of the biggest problem of our environment nowadays. And I assuring you, AKS University Cement Technology Department will do the research for controlling this problem. And also in future, we are supporting for solution of this problem. Now I would like to request Dr. B.N. Mahapatra to present the memento to our chief guest. Present Ganpati ji as a memento from AKS University Satna to our chief guest. Thank you, sir. AKS University is very much thankful to you. You have given your valuable time to us and honoring us. Thank you, sir. Dr. Ashok Kumar, Deputy Director General of Energy Efficiency, Ministry of Energy, Government of India. He is presenting keynote address of this conference. And due to some unfavorable avoidances, he is in online platform. And I welcome Dr. Ashok Kumar, sir, Deputy Director General, Bureau of Energy Efficiency, Ministry of Energy, Government of India, for keynote address. I request the guests sitting on the dais, please be seated in front of dais. Yes, sir. I think there is some technical issue, and that's why they are taking so much time. Sorry for inconvenience. Within a few minutes, we are starting the keynote address.
Just to highlight that, I think DG, NCCBM would and the other dignitaries would enlighten you on further details of why such an exercise is of very importance, and particularly for the cement sector. Cement sector being one of the more energy consuming sectors of the economy. So we attach a lot of importance to the sector, and sector has contributed tremendously in the energy efficiency space and the broader climate change mitigation exercises. In this, the due course of time, we have realized that the WHR is a very strong instrument that has been exploited by the cement sector in the last 10 to 15 years. And we are told that around 700, 800 megawatts of generation is coming from WHR, and you still have around similar capacity to be exploited. So in that context, this system or this interventions become very important for the sector. And we are looking forward for many more interventions in this area, as well as in many other areas that I think DG NCCBM would elaborate on. So we are looking forward for a very fruitful discussion in this workshop, and also insights from your side, so that operating agencies like Bureau of Energy Efficiency can be enabled to create better enabling ecosystem, better enabling for support systems, so that the sector takes even more responsibilities to come in the times to come. You are acknowledged that cement sector is currently the best in the world, and we recognize and we congratulate the sector for your tremendous work. And many of the lead industries of the cement sectors are present in this group. So we are looking forward for your kind inputs and insights, so that we can further improve upon the sector's efficiency and, of course, the contribution to the climate issue. So with that, I would also request that this is one of the series of workshops that we have conducted. It was started in Delhi in the first, and you would appreciate that it was attended or the kind of blessed by the none other than the additional secretary to the DPIIT. So the importance of this particular exercise is very well recognized at the top level of the government. And the Director General of Bureau of Energy Efficiency has indicated several supporting systems, supporting mechanisms to support this WHR intervention. And I would be happy to inform you that WHR, some kind of incentive proposal for the WHR is under consideration at the Ministry of Power, and also certain enabling financial instruments that are being developed to kind of support finance in the financing of such projects. So we are looking forward for your support, your leadership, energy efficiency, and other interventions. You would be of course, this is one of the interventions that cement sector undertakes. You have several other options of fuel substitution, material substitution, and the other interventions of carbon capture, and many other interventions where the cement sector is leading. So we would look at that leadership in the future to come, and we would be kind of supporting from the bureau side, whichever way it is possible. So I, on a personal account and on the Bureau of Energy Efficiency and officials there, I again welcome and thank you for your participation, and looking forward for the deliberation of this workshop. And I also kind of congratulate and thank the leadership of the NCCBM, the DG, Dr. Mahapatra, that he has pulled all together. And I can see several of you, not only the cement industry, but consultants, other experts joined together here. So cement sector being one of the leading sector with so much of expertise and the capability. So the country or the bureau, the ministry is looking forward for you to take even more responsibility in the times to come. As you know, the country, the government has, or the Honorable Prime Minister has raised the ambition in the COP26. So will be the responsibility of the sectors like cement. So we would be looking forward for your cooperation, support, and the insights so that we can broadly, not only in the cement sector, but learnings from your sector can be taken to other sectors. Several of the cross-sectoral interventions can benefit from your expertise to the other sectors. So looking forward, I once again thank you, and on behalf of the Bureau, again, welcome. And I take leave because I have to proceed for another meeting. I would certainly be love to be part of this deliberation, but certainly I would be looking forward for your insights. Thank you to all the dignitaries on the dais to kind of enlighten with their pool of wisdom. Thank you very much.
Thank you, sir. You have given your valuable time to us and give the immense knowledge to our students in the field of carbon emission. Now, I would like to invite Dr. Harshvardhan sir, Pro Vice Chancellor Development, AKS University Satna, for address the gathering.
First of all, I welcome all the delegates who have come to this university for the conference, for this seminar. I heartily welcome Dr. B.N. Mahapatra, who is Director General of NCC-BM, and Shri Sunil Khandare, Director, Bureau of Energy Efficiency. Our other guest, Mr. V.K. Rotary, who has left this conference hall, but I am also grateful to Johnson Print Cement that he came here and delivered his valuable thought before us. So I also appreciate and admire Dr. G.C. Mishra that he has organized a conference here with the industry authorities. It would be an interactive session for the betterment of the industry, particularly waste heat resurgence and its recovery system, how it should be rectified, how it should be minimized. This is the problem of the industry and the India itself. Our Honorable Prime Minister has already suggested that the carbon emission should be reduced. So carbon dioxide emission in the industry, particularly in the cement industry, is almost about the 60% goes waste. How to recover it, how to reuse it. The technology has already been given in the world. In India also, Bureau of Energy monitors the need of the cement industry, and they advise to the cement industry as well as the other sector also. It is required for every sector wherever the waste energy is generated, how it should be utilized for the welfare of the, not only for the society, but for the furtherance of the production of the cement and other sectors. So it is a very nice subject which has been identified by our cement technology department. All cement technology people, our professors, our students shall be benefited with this deliberation. And I, on behalf of the AKS University, I can say this much, that it is the need of the hour to discuss such a vital issue in the academics. Because in India, now the industry and academics must come closer. They must come close. Because in the changing scenario, the Government of India has already introduced a new education policy 2020, and it says that there should be a close linkage between the industry and the academicians. So I heartily welcome all the delegates from the different cement units that they have taken pains to come this university, and they will also share their experiences with the participants as well as our students will understand what is the importance of CO2 emission and how it should be reduced. And once again, I welcome on behalf of AKS University. This is the university which has been established in 2011, and it is growing, and it has been awarded various award by the Honorable Ministers of Government of India and the Honorable CM of Madhya Pradesh, and it is upcoming the best in university in Central India also. So thank you very much for giving an opportunity to me, and once again I also appreciate Dr. G.C. Mishra that this type of deliberation must continue, because we are in future also we are going to invite other industry also for the discussion, for the betterment of the society, how our education system should be also revitalized, how it should be reformed, because with your experiences, we would be able to reform and improve our academic sessions, our academic syllabus, and our practical sessions. So for the practical purposes, this type of deliberation will be beneficial not only for the students, but it will be beneficial by and large to the entire academic fraternity. So thank you very much. Our Dean, Dr. Tomar, Dr. Bihar Sahab, he is ex-chairman of PSC, Dr. KP Soni, who is regional officer of Pollution Board. He is also kind enough to participate in this seminar. I hope that air pollution is also a very vital issue of this country or for Madhya Pradesh. So please share all in the interactive session, whatever in your mind. Thank you very much.
Thank you, sir. Thank you, sir. AKS University feel pride to welcome our guest, Sri Bhaskar Bhattacharya ji, President, Satna Cement Work, Birla Corps. I request, yes, sir.
I missed one opportunity. Our very dear, I should not say only the president of Satna Cement, but he is a very good friend of mine also. Dr. Shri Bhaskar Bhattacharya, president of Satna Cement, is kind enough to come and in this conference. I welcome on behalf of AKS University that you have been very kind to present here. Thank you very much.
Thank you, sir. I request Director Cement Technology, AKS University Satna, Professor G.C. Mishra, sir, to welcome our guest, Sri Bhaskar Bhattacharya ji, President, Satna Cement Works, Birla Group Corp. Please, student, please coordinate and give the bouquet. Professor G.C. Mishra, sir, is welcoming our guest, Sri Bhaskar Bhattacharya ji. Now, I would like to invite Dr. B.N. Mahapatra, Director General, National Council for Cement and Building Materials, for giving their address and addressing the gathering.
Very good morning to all. Really, we are very much impressed to see the arrangement has been done by AKS universities So our thanks to AKS University first with a clapping. Really, I am honored to our Vice Chancellor, Dr. R.S. Tripathi, Dr. Harshvardhan, Pro Vice Chancellor, AKS University, and overall Mr. G.C. Mishra, Dr. Professor G.C. Mishra, who has taken so much pain to make this arrangement wonderful. This is beyond our expectations. Similarly, also, we are very much thankful to the Mr. Payback Period to accept our invitation in short notice and to prepone these programs only for his availability, because whenever we are conducting this program in the clusters, we generally invite the senior most person in the clusters to address this gathering. Dr. Ashok Kumar, thankful to Bureau of Energy Efficiency also at the same time. Entire team, Dr. Ashok Kumar, Dr. Deputy DG, Bureau of Energy Efficiency, and Mr. Sunil Khandareji, who is in DAS. Beside that also, where Mr. Keralaji is also having a vast experience in the cement industry and so working with the Bureau of Energy Efficiency, giving us so much inputs to the Indian cement industries in the Bureau of Energy Efficiency sectors. And our presidents, Satna Cement, Mr. Bhaskar Bhattacharya also here. Besides that, the industries, students, academia, and pollution boards. I recall that day, I was also working with Mr. Soni when I was there in the Vikram Cement Works as a quality chief. At that time, Soniji will recall that the things not possible has become possible in Madhya Pradesh Pollution Control Board with your supports. Entire problems of the police departments, that opium mark disposal, opium mark, not opium mark, that is the poppy straw. In 3 operations, we made it disposable in Madhya Pradesh, in Vikram Cement Works, with the support of the Madhya Pradesh Pollution Control Boards. That time DDG, collectors, all were aligned that. But these people suggested my name, that time pollution boards, that if you can go to Dr. Mahapatra and Vikram Cement, it was possible. And without the support of pollution boards, it could not be possible. I think Mr. Soni may be recalling that period. Entire materials, opium marks, in police department disposed in cement kiln. If Indian cement kiln and cement industry will not support, now there is not disposal of this type of material in India. So we should thank our Indian cement industry fraternity in all respects. Those who are making this possible. And one material was there, you may be recalling that was not coded in the hazardous waste opium mark. Opium alcohol plants, they are having opium marks at the hazardous waste, but there is no technology to disposal. All the times there is under pressures, this pollution board people comes and tell, you dispose it off, otherwise you cannot return it. But they are asking what is the solution for this. So that time I recall Mr. Fahim Mohammad as the GM of the opium alcohol plants. He is the most IRS, he is now the GST commissioner in Hyderabad. That man came to Vikram Cement and saw all our operations. And Vikram Cement was aligned that time, all facilities to dispose any type of metal cement industry. And that time opium mark was a trial materials, that is not, and he told that if you can take interest, it can be soluble, or it can be possible. Again that time with the support of the Central Pollution Boards, Madhya Pradesh State Pollution Boards, Vikram Cement Industries, that we made it successful in 2 operations. After that, opium mark was coded as a hazardous waste after the successful trial in Vikram Cement. That is also for the cement industry. And that time we earned about revenue about 1 crore rupees from Finance Department, Ministry of Government of Finance Department. So during our career, as because you deal this type of material in our everywhere, so with the support of the industries, I started my career in Dalmia Research Institutes, Dalmia OCL plant, OCL Dalmia Group. Then I came to Ultratech Group. I was there for 7 years. Then I came to Mumbai as the corporate quality head in Lafarge Holcim with 22 years experience, past experience in the industries, cement industries. and research experience and my doctorate in the cement technology, I was selected by appointment cabinet committee of the Prime Minister Office for this position, Director General NCCBMs. So I should do the best things for the cement industries, which is expected of me. I have already passed about 4 years' time. 6 months is already there. Still then, the same energy will be there till the last time. And without the support of the students, university, academia, nothing can be possible. Because the students, they will have to wonder. Vivek Agnihotri, for the first time, he saw this facility in Satna Cement. And he praised like anything, because interconnectivity in India is very, very poor. Unless or until connectivity between the universities, institutes, students, industry is not there, our India cannot grow. All the brilliance of India is doing well and excel in the foreign countries. You can see the American doctors, 60% doctor from Indian brains, everywhere. So when we are having the fertile brains in India, why not to connect itself, the universities, academia, industries, and also plants, industries, so that we can excel. And Atmanirbhar India, our Honorable Prime Minister declared that India can be Atmanirbhar in all aspects. So for the cement industries, we are going to independent. We have already developed Bharatiya Nirdeshak Dravyas in NCCBMs, supporting all standard reference support to Indian cement industries. In that case, no Indian money will go to foreign countries. People are sending sample to FLS. I am requesting this forum, all our unit heads, and also quality and other heads. Everything can be possible in India. We cannot divert anything also other countries. So many works has already been done. On this seminars, I recall that day when Mr. Anil Agrawal and DGBE was present in that seminar. I was also fortunately present in Delhi. That day it came to the mind of the Anil Agrawal, who is the additional director of the DPIIT. He assigned this responsibility to DG, Bureau of Energy Efficiency, and also to me in the open forum, that you conduct such a seminars in every area, in all clusters, so that Indian cement industry will take the advantage, what we can do it. So this is the third seminar we are conducting in this cluster, Satna clusters. First one is conducted in Ballabgarh, our center there, having presence about 120 people from the industries and also exhibitors. Second seminar come from the Hyderabad. We are not very hopeful, Hyderabad, but you can believe. Hyderabad also about 130 people also there from the industry, and also about 8 to 10 exhibitors were there in Hyderabad. But in MP, the day the assignment has given to Mr. Professor G.C. Misra, he gladly accepted it that day. I recall that day. And with the efforts of AKS University and this highly dynamic, energetic man, Professor G.C. Misra, this seminar could have been possible here with the August gathering. He connected industries, he connected other students, he connected CBM and also Bureau of Energy Efficiency in the great manner. And this is the start, not the end. I request AKS University to do this type of programs in a series. You are having all facilities here. You have the competency, capability, everything is here. So you should utilize full potential of these universities. So these universities also to be in number 1, number 2, number 3 in the entire country. Why not? We'll explain for that. Our industries in Satna clusters, Prisms, Birla Corp, Ultratex, KJS, all industries already there. During my tenure, I give the equal importance to all industries, irrespective of the zonal presence. The southern, northern, central, even mini cement plants. So NCCBM giving the due weightage to all the industries and coming forwards for that, we have already made 22 expertise group in NCCBM to support in all sectors, not only energy. We are having expertise team starting from the mineralogy and all the 5 levers. The decarbonization 5 levers are already established. And as because our Honorable Prime Minister established that by 2070, India will be carbon neutral. This is a very, very high targets. Our cement sector and our steel sectors are the hard to our sectors. So they will have to perform well in all sectors. And you will be happy to know that Indian cement industry, and we become the part of the supplementary metal in India. We are blessed with the material. We are having enough fly ash, enough slag. And we are now producing about 67% of Portland Pozzolana cement, 10% concrete facility, so that nearby cement industry can take the advantage. So I think in the next two to 3 months, my expectation is there. So you make a concrete technology program again and be educated with the cement plants, so that what cement they are producing and what is that they are changing in the process, that all should see the incorporated in the concrete properties. If you are changing the process, if you are grinding from ball mill to BRM, if you are changing different type of gypsums, because of the care of the cement industries, and also concrete construction and also builders, it's parallelly going, it is not connecting now. I think, Bhaskarji, I am correct or not? So your care is that how to reduce the cost and better perform the cement. And concrete manufacturers, they are going to the market, they see that if the cement is performing not well, they are just accusing, you are using Prism, don't go to Ultratech. Ultratech, then you KJK. That is not the solution. Every cement should perform. And for that, one area is gap, that is technology of super plasticizers. You can change cement, you can change raw materials, you can change the requirement of the concretes. But one area is requirement again, that formulation of plasticizers, super plasticizers and additives. That also area has already come to AKS University. You can also think for that. So the second parameters, that alternate fuel and alternate raw materials. In India, in 2005 and 6, when we started this thing in Bikram and also in ACC Kaimur, we are giving so many presentations in Madhya Pradesh Pollution Board. These scientists are present in the forum, and Professor Gautam was there that time, the chairman, the microbiologist, to have the knowledge in the cement, other sectors. He has made a technology, made a system that every cement plant should come and present it. Sonit, you were there that time in Madhya Pradesh Pollution Board, Bhopal, that time, you recall? All scientists are there, and we have to give the presentations. They want questions for the scientists and also industries. So that is the best methodology for a chairman to understand all industries in sectors sitting in the Madhya Pradesh Pollution Board. At that time, when we opposed alternate fuel, every material, agricultural waste, hazardous waste, everything else, then this Professor Gautam came. If people are doing a very good things, why not plastic and polythenes? Then we took the pioneer role in the Bikram cement from Ultratech, and at the same time ACC Kaimur. Then you can just example I'm giving it, that visionary man, that Gautam, the chairman of the Madhya Pradesh Calcination Board, to these visionary minds, he implemented plastic polythene uses in the cement industry as a whole, and he made a roadmap how entire cement, plastic and polythene become usable in the Indian cement industry. And this is one of the things he has taken by that time. You will be happy to know that I also have highest regard to him. He became the chairman of Central Pollution Control Boards. So my student, this is my vision to the students. You should be visionary. Think differently. Be innovative. Everything is possible. That is example, microbiologists become the chairman of the CPCB, Central Pollution Board, because this activity has taken by that time. Kya Soniji, I am right or wrong? आप थोड़ा सपोर्ट करो, मध्य प्रदेश पॉल्यूशन बोर्ड के आदमी है ना यहाँ पर, so I will take the full advantage of your presence here. Then उस time this RDF, municipal solid waste, was not permitted in India that time, whether it is hazardous or non-hazardous. So municipal solid waste plant was being set up in the Langiri Abbas by Ultratech Cement Limited in Rajasthan, and that metal is supposed to come to Bikram Cement, Madhya Pradesh. There is a conflict, Pollution Board of Rajasthan and also Madhya Pradesh. Madhya Pradesh board told, why will allow the kachada of the Rajasthan to use in the Madhya Pradesh Kiln? It is Rajasthan waste. You incinerate in the Rajasthan. But ultimately solution is there for India. So I took the lead, and also Professor Gautam visited that plant. And it is the solution for all over India, not the states. So don't be very far short-sightedness. be farsighted, and we have to solve the problem of the Indian cement industry. And that time, RDF for the first time got the permission as a non-hazardous waste in India. So we got the permission so that everybody is now using it, RDF. So similar type of initiative we have taken by that time, as a result of which Indian cement industry is highly successful, and without Indian cement industry, our country cannot achieve to that extent. Similarly now, PLC, Portland Limestone Cement, Portland Dolomite Cement, Portland Composite Cement, all has already become successful, submitted the draft to the BOP Indian standard. So people can try. And we are taking the industry partner, because after the laboratory trial, it should be validated at least certain quantity in the plants. So after that, the results will also validate to BIS to take the standards. That one stage, we are now requesting all the plants to take a trials, and also the permission, NCCM can part for that also. So you can make some trial in the plants, and you can send the result to BIS so that the standards can come at the earliest. Alternate fuel, where already in India has become 6% TSR. From 1 to 2%, it takes about 10 to 15 years time in India. Why? First of all, any new things comes, we resist it. That is in Indian blood. We don't accept the new things easily. If we are comfortable with coal, why will we use plastic and polythene? So the resistance, जो आदमी पहले उसको निकाल दिया, they become the successor. Now you can see that some of the leading plant is using 30% TSR. That is beyond the imaginations. And plastic polythenes beyond 300 microns is completely utilized cement kiln as a fuel value. Agro waste, hazardous waste, tire chips, all type of material which is having energy value, that can be successfully utilized in the cement kiln, as because cement is having a high temperature furnace, and all it is also having enriched with alkali, so it can digest everything else. So earlier people are telling it is a highly polluting plant, no doubt, but it is also helping other industrial waste to digest and assimilate in Indian cement kilns. Recently there is an article I have already published in our Times of India, how Indian cement industry is helping for the disposal of hazardous waste in India. So these are the very, very new things people are doing it, and also are supporting now in every respect. Sustainability. If limestone deposit is only for 25 years and coal is only for 30 years, then how cement industry will sustain? So for that already all high-grade limestone or dolomitic limestone, low-grade limestone can be utilized in cement industry, and so that our limestone deposit can be enhanced by 15 to 20 years. So that type of research is required by NCCVMs and implemented the Indian cement industry to support it. That third lever or fourth lever, fifth lever, this is the third lever, waste heat recovery, for which we are assembled here. First, we are doing well. Second, also we are also not in a very bad shape. 6% TSR in India is not bad, because it is as because in volume wise we are also higher. That's why we are also equivalent to 85% in other countries we are doing the AFR. But still now we see that coal cost has increased by 3 times. So if you have not done this thing earlier, then you cannot utilize this thing, also cement kilns. So pet coke, coal, the rate has gone drastically higher, even 3 times. So as because we have already innovated this thing, alternate fuels, so people have started using AFR, and also alternate fuel also going up to 30% TSR in some of the leading plants. And this waste heat recovery, there is the highest potential is there, waste heat recovery. People can do it also to that extent. The total installed capacity waste heat recovery in Indian cement plants has increased from 107 megawatt in 2011 to about 800 megawatt in 2020. The total potential waste heat recovery in Indian cement plants is about 1300 megawatt. So this seminar will definitely give you the inputs to the industries and also our academia and also the suppliers, how to get the best utilization of this waste heat recovery in the Indian cement plants, so that our third lever also we can achieve it. Fourth is improving energy efficiency, thermal energy, electrical energy, everywhere. We should also excel. So if the 4 parameters are achieved, at least we can go up to 30-35. We can achieve certain substitution, because our carbon dioxide emission in 1.17 was in 2017. Now it is 0.5767 in 2018. But further we can decrease it by employing all these 4 parameters. Fifth parameters, the challenging, most challenging parameters, that is newer technologies, renewable energy, novel cement, carbon capture and storage and utilizations. Already people have done the good things in renewable energy also. Here also I have seen the Prism cement, also today I will see the Satna cement also. In the renewable energy also people, cement industry is doing well. And only carbon capture and storage, that a new concept is coming, for which actually Government of India has nominated me also to use that plant, Sweden, Heidelberg cement, which Agrivatri already told. Heidelberg cement, whole seams, they are doing some new things in carbon capture and carbon storage and utilizations, but it is now cost economics. It is highly costly. But if today we do the research, maybe after 10 years it will be feasible, as in the case of the alternate fuels. So that is the fifth area. If we cannot use the fifth area, then carbon neutrality is a dream for India. So we have to go for that. So I have already explained, 22 expertise group is already there. NCB is also carrying out so many energy audits, so many energy auditors are there. So we are also closely working with the Bureau of Energy Efficiency in the different sectors. Now yesterday we have a talk with Sunil Khandariji. Why not we introduce this type of course in the students also, student curriculum? That environment monitoring, energy monitoring. So the students should read from the very beginning, what is this thing happening? Nowadays, I am also the member of the so many board of studies in the different universities. And we have now tied up with the 11 IITs and 15 NITs. And also I give the equal importance to the private industries, Calcutta universities and other AKS, other universities also. So do not discrimination that government university, private university. If you are doing well, we will give support everywhere else. So this carbon capture and utilization, there is another group. We will also educate this thing with the different webinars. This will take time. So now, 17th NCB International Conference is already fixed in 6 to 9 December at Manekshaw Center, New Delhi. This is one of the important seminar. Now this time we have made it conference, not seminar. When the people, about 1400 people comes, about 100 delegates from the outside countries coming, we have changed the name from the seminar to conference. And this 17th NCB conference will give a highest mileage. And we are connecting all Indian cement industries, concrete industries, students. We are having the separate session for the students where the IITs, NITs and other university students also can participate. So I request the Chancellor, Vice Chancellor here also, this time you should also attend the seminar. Also you select 1 to 2 students also to participate, because the same list we want that AKS University should be also participate in the same student session. So I request in this forum, actually we are having a leaflet also there. Already that is the highest progress. All the Indian cement industries are aligned to be the member of the 70th conference. There is a paper publications, presentations, and award ceremony, not just like energy, environment, total quality management, and this time we introduce circular economy. Now NCCPM is working with all the ministries, like DPIIT, we are working for the circular economy gypsums, we are the part to make the standards. How this gypsum is plentifully available in Odisha, and import will be stopped by certain days. So our 66 million ton of gypsum is there in Odisha, IPCO and Paradip Phosphate, and also other parts that will completely utilized. That monitoring is being done by Niti Aayog very strictly. So it is my message to the Indian cement industry, you be equipped to use the phosphogypsums, and there is no alternative, you have to use it. Similarly, other thing, Ministry of Environment, Forest and Climate Change, that also carbon dioxide reductions, and this newer energy, carbon capture, carbon sequestrations. We are working closely with the MOFCC also. Then also industry, we have to connect industries and the government. Our NCCPM will role connectivity of the industries and connective ministries, and how Indian cement industry is connected. So that also we are working with the MOFCC. And we have been nominated as the 2 of the prime members for the chairman of the, by Niti Aayog, for the C&D West, and also circular economy gypsums. And also power, FGD gypsum. That is the waste of the NTPC, not waste, that is a value-added product. That also FJD gypsum also utilized in this Indian cement industry, and that is also, that is a good product that a thermal power plant is also producing. That also NCCBM has been nominated by Minister of Power to take the roles, and we have taken the prime role to make the standards for the FJD gypsums. So now the connectivity of our government bodies has increased manifold, and now we are connecting industries also in all sectors. So now it is the highest time to take the advantage of this type of webinars, to showcase the things, listen the properly, and also have your question answered correctly, so that our India can grow and we can also achieve the mission of our Honorable Prime Ministers by 2070 carbon neutral, and in all other sectors should be prime one. Because the blended cement, we are 72% and we are going to 100%. That also we can achieve it. So again, lastly, my thanks to Bureau of Energy Efficiency, our thanks to National Council Cement and Building Materials. Our Mr. Ankur Mittal is the man who is coordinating from the energy sector, all the cement industry. As because we are having 22 expertise groups, so in every teams we are having the leaders. He is coordinating with all the industries. And thanks to our Bureau of Energy Efficiency, starting from the DG, DDG, and Sunil Khandaraji, Mr. Negi, Mr. Kerala Saab, all these people, they have taken it very seriously. That's why this program is going to be successful. So, and lastly, AKS universities, without the facility, this seminar would not have been possible, and I hope that in the concluding session, I will again attend, and this objective of this seminar will be fulfilled to about more than 100%. So that means it shows a clarity is there, our university connectivity, government connectivity, and NCCBM's prime role in every sector to achieve it. So thank you very much. I am having high expectation of this seminar. So please listen to the all sessions very carefully, and also interact the questions, so that in the concluding sessions, I should hear from you what benefit has gone to you after this seminar. And this report is being monitored by the highest authority, Niti Aayog, Bureau of Energy Efficiency, and also NCCB and DPIIT. So that so many people are here to take the full advantage of this seminar and conference. Thank you very much.
Thank you, sir. Just I want to add 2-3 lines what Director General NCCBM has suggested. I can proudly say that we are having a cement and concrete lab NABL accredited. That facility can the cement industry take. And regarding other laboratories, we are having a state-of-the-art biotechnological lab, where the cement industry can take the projects of the biotechnology, how it will be utilized for the cement sectors. We are doing the consultancy in the mining sectors. We are having a green chemistry lab where we are utilizing the leaves, the plant leaves, we are utilizing for the production of paints. And the polythenes for using, and in there we are generating the diesel-like material which can be used for the fuel as a fuel in the vehicles. That we are doing in this campus also. And all the campus, we are doing the skill development program on the concrete sectors for the masons, for the lady silpakar, and for engineers. And what the Director General has suggested, he is the member of our board of study, he is academic council. And regarding energy audit, our course is having an energy audit, but we want to make it more dynamic and how it will be utilized by the industries. More, that means more practical oriented. We are having an environment course also. That also will make it as per the utilization of the industries. And with this, in the concluding session, I will tell more about what university having the facilities, which the industry should take the advantage of that, because we are sitting in the Satna clusters. And it is your university, the industry people I am saying, you take the advantage of this, you take the advantage of this auditorium, these forums, and at least in every year, we should organize a technical forum to exchange our ideas, and then everybody will be benefited as well as the country. Thank you.
You will be happy to know that today in the afternoon, NCCBM is going to have a memorandum of understanding with AKS universities for the all collaboration, the research, sharing of the laboratories, and sharing the facilities, and also PhD degree. So thanks our AKS universities in the afternoon. We will make the conduct of the MOU in the afternoon with the vice and pre-vice. Thank you very much.
Thank you, sir. Thank you for your valuable words. Now, I would like to invite Dr. Sri Bhaskar Bhattacharya ji, President, Satna Cement Works, Birla Corp, for address the gathering.
Respected Mahapatra Sahab, Director General NCCBM, Sulil ji, Director Bureau of Energy Efficiency, respected delegates on the dais, Soni sir, ROMP Pollution Control Board, Kalra sir, and all respected colleagues and dear students. Thank you. I feel highly honored that Bureau of Energy and NCCBM has selected the Satna cluster for the third seminar to be conducted on reduction in the carbon footprints. Thank you so much, sir. We from the Satna, we are honored. I'm basically from Satna, working around the Satna, associated with AKS University. I feel honored for this opportunity given to us. And I'm also thankful to AKS University for being associated the Birla Corporation in this seminar. Friends, reduction of carbon footprints. We all know that without this, our coming generations cannot survive. This question of our survival. So, and I'm happy to be associated with this cement industry, which is the leader in the reduction of carbon footprints and absorbing different kind of waste, starting from this fly ash. Imagine if the cement industry is not utilizing the fly ash and generating as a useful product, what would have been the condition today? If we were not being utilizing the different waste which we have started using since maybe last 6-7 years, the hazardous waste. Earlier we have been called as a polluting industry, but now we are proud to say that we are pollution absorbing industry. The municipal waste, if we talk regarding the Delhi, there were big heaps lying over there and polluting everything over there. But now, with the initiative of different agencies, the involvement of NCCBM, these different processes have come, due to which we are able to use it. I am also happy to tell Mahapatra ji that Satna Cement at present is using around 12 to 15% of alternate fuels. And by 23 December, we are upgrading our systems to utilize about 25%. We are also in dialogue with the Municipal Corporation of Satna to establish a system over here so that we can have RDF from them. They can segregate these all municipal waste, and it can be created for a useful alternate for the society, for the industry. So friends, it's a great opportunity for all of us, for the students over here, to hear from different delegates. I would not take much of time. Only request you all to be participative during the seminar, during the talks, so that any question what you have, you ask for it. Otherwise, the question will remain inside you and you will not get the answer. Don't hesitate to ask any question. And thanks once again, Mahapatra ji, AKS University and Bureau of Energy Efficiency for organizing this seminar over here. Wish you all the best and thank you very much.
Thank you, sir. Now, I would like to invite Honorable Vice Chancellor, AKS University Satna, Dr. R.S. Tripathi, sir, to address the gathering.
डैश पर अग्निहोत्री साहब का मैंने वक्तव्य सुना, महापात्रा जी का वक्तव्य सुना। मैं अपने राष्ट्र को नमन करना चाहता हूं। जो पहले उन्होंने बताया अपने देश के लोग वहाँ कैसे रहते थे, आज हमारा देश संघर्ष करते करते कहाँ पहुँचा है। यद्यपि आज की स्पीच, टेक्निकल स्पीच मिश्रा जी ने मुझे तैयार कराई थी। चूँकि मैं सारी टेक्निकलिटीज़ को जानता नहीं था तो उन्होंने मुझे एक बहुत अच्छी स्पीच बना के दी थी। बट मैं महसूस करता हूँ कि हम तैयार करके कोई स्पीच दें और उसके पुरोधा यहाँ बैठे हैं जिनको तैयार नहीं करना पड़ता, तो अच्छा रहा। उस स्पीच को मैंने जेब में रखा है, मैंने रिजेक्ट किया उसको। आज जो गैदरिंग है, महापात्रा जी, अग्निहोत्री साहब चले गए, टाइम नहीं था। महापात्रा साहब बैठे हैं, भट्टाचार्य साहब बैठे हैं, सुनील सर बैठे हैं और प्रासाल में हमारे इंडस्ट्रीज से आए हुए इंजीनियर्स, ऑफिसर्स और हमारे विश्वविद्यालय के सीनियर प्रोफेसर्स भी बैठे हैं। इस कॉन्फ्रेंस से मैंने 3 बातें, वैसे तो महापात्रा साहब ने बहुत डिटेल में बताया, अग्निहोत्री साहब ने बताया, रिडक्शन इन कार्बन डाइऑक्साइड एंड हीट और बेस्ट यूज ऑफ वेस्ट। 3 मोटी चीजें मैंने नोट की। कार्बन डाइऑक्साइड कम होगी, इन्वायरमेंट में चेंज होगा, ग्लोबल वार्मिंग में चेंज होगा, इसलिए बहुत ही महत्वपूर्ण है। लेकिन इसके पहले कि हम कुछ भी टेक्निकल कहें, मेरा एक रिलीजियस ड्यूटी है कि मैं बार बार इस मन से, जो बाहर से लोग आते हैं तो अपने विश्वविद्यालय के विषय में मैं ज़रूर कहता हूँ, ये मेरी ड्यूटी में है। ये विश्वविद्यालय सन 2011 में मध्य प्रदेश सरकार ने विधानसभा में पारित अधिनियम के द्वारा स्थापित किया। बिल्कुल संक्षेप में बताना चाहता हूँ। और आज इस विश्वविद्यालय की स्थिति है कि जितनी रेगुलेटरी बॉडीज हैं, यूनिवर्सिटी ग्रांट्स कमीशन, ICAR, NCERT, PCI, AICT, सभी से मान्यता प्राप्त है। अभी प्रश्न एक उठाया था भट्टाचार्य जी ने, तो मुझे अच्छा लगा कि मैं उस पर क्लियर कर दूं कि प्राइवेट यूनिवर्सिटी में और गवर्नमेंट यूनिवर्सिटी में केवल इतना अंतर है, केवल, मैं केवल शब्द का प्रयोग कर रहा हूं, गवर्नमेंट यूनिवर्सिटीज को कुछ फाइनेंस देती है सरकार, अभी प्राइवेट यूनिवर्सिटीज को नहीं देती है। लेकिन उस पर भी विचार हो रहा है कि ये फाइनेंसेस प्राइवेट यूनिवर्सिटीज को भी दी जाए। करिकुला, डिग्री एकदम बराबर है, ये आप कॉन्फिडेंस रखें, मैं इस बात को अथॉरिटी से कह रहा हूं। इस विश्वविद्यालय का नाम AKS है। AKS का जो एकेडमिक फुल फॉर्म है वो है एमिकेबल नॉलेज सॉल्यूशंस, मतलब ज्ञान किसी के ऊपर कोई सॉल्यूशन जो ज्ञान के द्वारा होता है वो थोपा नहीं जाता है, आपस में पूर्ण विचार करके, विस्तार से विचार करके ही उस पर होता है कि ये अल्टीमेट बात है। ये नहीं कि एक प्रोफेसर ने कह दिया तो उसी को हम अल्टीमेट माने, ये एक विशेषता है। आज इस विश्वविद्यालय में 12 फैकल्टीज हैं, लगभग 52 डिपार्टमेंट्स हैं, और मान्यता के विषय में मैंने बता दिया। विशेषता एक और है, वो ये है कि यहाँ पर कंट्री में किसी और यूनिवर्सिटी में नहीं, यहाँ सीमेंट टेक्नोलॉजी पढ़ाई जाती है, जिसका कि सीधा संबंध सीमेंट इंडस्ट्रीज से है। इस अवसर पर मैं जरूर कहना चाहूँगा कि जो सीमेंट में करिकुला पढ़ाया जा रहा है, मैं ये ऑफिसर्स बैठे हुए हैं, महापात्रा जी से भी मैं ये बात कहूँगा कि सीमेंट इंडस्ट्रीज में जो इंजीनियर्स हैं, जो ऑफिसर्स बैठे हैं, अगर कोई चीज़ ऐसी फील करते हैं, कोई बारीक बात ऐसी है, वो मिश्रा जी को, डायरेक्टर को या वाइस चांसलर को या विश्वविद्यालय के प्रो चांसलर को सीधे लिख सकते हैं, जिससे हम अपने एकेडमिक काउंसिल में रख करके, यहाँ 50 विद्वान उसमें बैठते हैं, उस पर विचार करते हैं, जिससे हम करिकुला में उसका ऐड कर लें, हमारा करिकुला और अच्छा हो जाएगा। मैं महसूस करता हूँ कि जो इंडस्ट्री में, सीमेंट इंडस्ट्री में पहले इंजीनियर्स जॉब करने जाते थे, तो बेसिकली उनको सीमेंट की नॉलेज नहीं होती थी। वो बीटेक किसी में है, कोई किसी में है, कोई किसी में है, फिर वो उसी इंडस्ट्री में देख करके कुछ काम करके सीखते थे। आज वो सारी चीज़ें यहाँ सिखा करके उनको भेजी जा रही हैं। बट इतनी अपॉर्चुनिटी अवश्य है, आपके लिए लिबर्टी है, और आप अधिकार स्वरूप ये मैं चाहता हूं कि आप लोग अपने सजेशंस देंगे, जिससे हम पाठ्यक्रम में और भी परिवर्तन कर लें और इनरिच हो जाए पाठ्यक्रम, ये मैं चाहता हूं। इस विश्वविद्यालय के लगभग 200 MOs हैं, विदेशों में भी हैं, और ये इंडस्ट्री के बच्चे फॉरेन जाते हैं, वहाँ से सीखते हैं, उनका अपॉइंटमेंट भी होता है। तो ये मेरा इसमें आप लोगों से निवेदन होगा। और एक विशेषता और बता रहे हैं, यहाँ पर माइनिंग इंजीनियरिंग मतलब फैकल्टी 12 हैं, 52 विभाग हैं, लेकिन संयोग देखिए कि माइनिंग इंजीनियरिंग, सीमेंट एंड सिविल एकदम स्ट्रेट लाइन पर हैं, जिसमें उस नॉलेज को टेस्ट करने में कहीं बाहर नहीं जाना है। दो एकदम कनेक्टिविटी उन सब्जेक्ट्स की है और हाई लेवल पर उनकी पढ़ाई हो रही है। मैं यह चाहता हूँ, हमारे MOs हैं, इंडस्ट्री के लोग यहाँ पर ज़्यादातर PhD करने के लिए अट्रैक्ट होते हैं, और यहाँ पर उनको कोई ज़्यादा उलझन न हो, पूरी मदद की जाती है उनकी रिसर्च कराने में। अपने पास उसके वैज्ञानिक हैं, तो इसलिए सीमेंट इंडस्ट्री में जो हैं लोग, ऐसा अगर चाहेंगे तो मैं मुझसे MO कर सकते हैं। दूसरा एक और है कहना मेरा कि सीमेंट इंडस्ट्रीज के लोग अगर कोई सेमिनार कराना चाहें अपनी खुद इस हाल में अथवा अपने यहाँ ही कराना चाहें तो यूनिवर्सिटी उसमें पूरा पार्टिसिपेट करने को तैयार रहती है। क्योंकि यहाँ पढ़ाई का काम है, इसमें अगर आप 1 हफ्ते या 5 दिन के इंटरवल पर या 3 दिन के इंटरवल इन्फॉर्म करेंगे तो यहाँ प्रोफेसर तैयार रहते हैं आपके साथ शेयर करने के लिए, आपके स्थान पर अथवा इस स्थान पर। ये भी मैं कहना चाहूँगा। एक बात और कहना चाहता हूँ, इस विश्वविद्यालय के चांसलर बीपी सोनी हैं। उनका कुछ स्वास्थ्य ठीक नहीं है, नहीं तो अवश्य आते हो। उनकी एक विशेषता है कि जो इस समय पूरे विश्व में एक डिसहार्मोनी सी क्रिएट है, विद इन द नेशन, आउट ऑफ नेशन, उस पर उनका एक चिंतन है। और चिंतन उनका जो शुरू हुआ वो कॉन्फ्लिक्ट विद इन द मैन। मनुष्य में खुद कॉन्फ्लिक्ट होता है और उसी से समाज बनता है, उसी से देश बनता है, उसी से विश्व बनता है। उन्होंने आपस में हार्मोनी रहे एक विचार किया कि वर्ल्ड गवर्नमेंट होना चाहिए। जैसे हम अपनी सरकार में विचार विमर्श करते हैं फिर निर्णय लेते हैं, इसी तरह से विश्व स्तर पर कोई अगर सरकार बनती है तो शायद ये जो डिसहार्मोनी है वो हार्मोनी में बदल जाए और विश्व का विकास, प्रत्येक देश का इंडिविजुअल विकास और विश्व का विकास संतुलित विकास हो और मानव जैसे ही जी पाए, उनका ऐसा विचार है। एक चीज में थोड़ा सा मिस कर गया, इस विश्वविद्यालय में फैकल्टी ऑफ लॉ अभी खुला है, तो इंडस्ट्री के लोग, बहुत से लोग ऐसे होंगे जो पढ़ना चाहते हैं, चूँकि उसमें एज का कोई प्रतिबंध नहीं होता। तो मेरा ये इस समय इतना ही कहना है और रिक्वेस्ट है कि हमारे पाठ्यक्रम में अगर कोई चीज़ आप अपने विचार करके रीजनिंग के साथ दें, वो लोग हम लोग विचार करेंगे। हमारे पास बहुत ही सोफिस्टिकेटेड लैब है। धन्यवाद।
धन्यवाद sir. Now I would like to invite Shri Sunil Khandare, Director Bureau of Energy Efficiency, Ministry of Energy, Government of India, for address the gathering.
थैंक यू, गुड मॉर्निंग टू ऑल। पहले तो मैं त्रिपाठी साहब को धन्यवाद देना चाहूँगा कि बेसिकली इंडस्ट्रीज़ और एजुकेशनल इंस्टीट्यूट्स का जो गैप है वो कम करने के लिए जो सहायता AKS यूनिवर्सिटी ने दी है वो काफ़ी सराहनीय है। मैं हिंदी में इसलिए शुरू कर रहा हूँ ताकि मैं देख रहा हूँ कि कई स्टूडेंट्स यहाँ पेशेंटली स्पीकर्स को सुन रहे हैं, कई फैकल्टीज़ भी है। इसका इम्पोर्टेंस इसलिए है कि शायद स्टूडेंट्स को पता नहीं चल रहा है कि ये सेमिनार किस चीज़ के लिए है, WHRS होता क्या है। थोड़ा सा मैं BE के बारे में बता दूं कि ये स्टूडेंट्स को क्यों सीरियसली थोड़ा सा लेना चाहिए कि ब्यूरो ऑफ एनर्जी एफिशिएंसी मिनिस्ट्री ऑफ पावर की एक स्टैट्यूटरी बॉडी है जो कोई केमिकल, मैकेनिकल या दूसरे स्ट्रीम्स में ग्रेजुएशन करता है और उसके बाद 1 साल का अनुभव लेके, मतलब ये जो ग्रेजुएट्स है वो लोग एनर्जी मैनेजर और ऑडिटर का कोर्स अपीयर करके एक सर्टिफिकेशन ले सकते हैं। और अभी मैं कल महापात्र साहब से भी बात कर रहा था, उन्होंने भी बात की कि एनर्जी ऑडिट एक स्पेशलाइज्ड प्रोफेशन है जो बेसिक क्यूरिकुलम में सिखाया नहीं जाता है। जैसे बिचारा साहब ने कहा कि कुछ एनर्जी ऑडिट से रिलेवेंट कुछ चैप्टर्स है, तो हम लोग सोच रहे हैं कि इसमें कुछ अंडर ग्रेजुएट लेवल पे एनर्जी ऑडिट की जो इम्पोर्टेंस है ताकि लोग इस एनर्जी ऑडिट को एक करियर के तौर पे देख लें और इंडस्ट्री में इसका योगदान कितना हो सकता है वो आप समझ पाएंगे। तो स्टूडेंट्स के लिए ये मैं रिक्वेस्ट करूँगा कि आप ये थोड़ा सा समझ ले ग्रेजुएशन के बाद, खास करके स्पेशलाइज्ड ग्रेजुएट जो है। ऑफ कोर्स हम लोग डिप्लोमा इंजीनियर्स को भी उसमें इनवाइट करते हैं, पोस्ट ग्रेजुएट्स तो है ही। मैं इसलिए इस फोरम में ये बात कह रहा हूँ क्योंकि एक 5 पॉइंट एजेंडा जो माननीय पीएम साहब ने जो अनाउंस किया है, उसमें 2070 तक नेट ज़ीरो कंसेप्ट एक दिया है उस 5 पॉइंट एजेंडा में। तो उस एजेंडा में जो 5 पॉइंट एजेंडा, उसमें अलग अलग साल के लिए अलग अलग टारगेट्स हैं। जैसे 2030 के लिए कोई कंप्लीशन है, 2047 तक है और 2070 है। तो हम लोग में से कई लोग पता नहीं होंगे नहीं होंगे, लेकिन जो लोग 2070 पार करेंगे उनके लिए ये इम्पोर्टेंट टारगेट्स है, खास करके CO2 एमिशन रिडक्शन के लिए। तो स्टूडेंट्स से मैं रिक्वेस्ट करूंगा कि आप कृपया हो सकता है तो टेक्निकल सेशंस अटेंड करें, समझें। आपको ये डिफ़िकल्ट ज़रूर जाएगा समझने में। आपको WHRS कोई इंडस्ट्रीज़ के लिए बहुत ही पॉपुलर टर्म है, लेकिन स्टूडेंट्स के लिए वैसे नहीं होगा, क्योंकि बहुत ही बेसिक लेवल से उनको समझना होगा ये चीज़। तो एनीवेज मुझे अच्छा लग रहा है कि स्टूडेंट्स भी यहाँ है, नॉट बिकॉज ऑफ फिलिंग दिस हॉल बट ऑल्सो पेशेंटली लिसनिंग टू ईच एंड एवरी स्पीकर। नाउ कमिंग टू द vote of thanks proposal, I feel really honored and privileged to get the opportunity to propose a vote of thanks on this occasion, and I would like to thank all the honorable delegates who blessed us with their presence. I am also thankful to the program organizing committee members and the invited speakers. On behalf of the organizing committee, I would like to convey deep regards and thank to Vivek Agnihotri साहब जिन्होंने शुरुआत की for its insight information over the seminar topic. Again, I am thankful to Dr. Ashok Kumar ji, who is our Deputy Director General, who is heading this NMEEE mission. एक बात बता दूं कि NMEEE mission is nothing but the industrial efficiency program, जिसमें perform, achieve and trade fall करता है, जिसके मतलब जहाँ पर as on date 13 इंडस्ट्रीज़ है। सीमेंट एक बढ़िया इंडस्ट्री है जो काफ़ी रेगुलेटेड है और पूरे इंटरनेशनल स्टैंडर्ड्स को मीट करता है। इंडियन सीमेंट इंडस्ट्रीज़ काफ़ी मतलब जब भी ये बात होती है कि भाई कौन से इंडस्ट्रीज़ को हमको नहीं रेगुलेट करना चाहिए या कम रेगुलेट करना चाहिए, वो सीमेंट है। ऑल्दो बताया गया है कि 1300 मेगावाट, जैसे महापत्र साहब ने बताया कि पोटेंशियल काफ़ी है इसमें। सीमेंट के अलावा स्टील में भी काफ़ी है, 1200 मेगावाट लगभग। तो ओवरऑल इंडस्ट्रीज़ में 5000 मेगावाट का ये WHRS पोटेंशियल है। तो अभी आपने सुना होगा कि DDG जी ने बताया था कि एक रिकॉग्निशन पॉइंट ऑफ व्यू से MNRE एक डॉक्यूमेंट बना रही है, जिसमें हम लोगों ने काफ़ी रिसर्च किया है और एक पॉलिसी डॉक्यूमेंट हमने प्रपोज किया है, जिसमें पॉसिबली WHRS को ग्रीन पावर रिकॉग्निशन की बात चल रही है। तो वो दैट कुड बी अ गुड हेल्प फॉर ईच एंड एवरी इंडस्ट्री। इनफैक्ट सीमेंट इज़ वन ऑफ द लार्जेस्ट ऑफ देम। तो वो डॉक्यूमेंट जल्दी आने वाला है और शायद कंसल्टेशन चल रहा है। हम लोग ने 2-3 कमिटीज़ फॉर्म करके उसमें काफ़ी इनपुट दिया है। काफ़ी सीमेंट इंडस्ट्रीज़ ने और बाकी इंडस्ट्रीज़ ने भी इसमें सपोर्ट किया है। तो लेट अस होप कि डॉक्यूमेंट विल बी अराइविंग सून। Extend my thanks to Mahapatra Sahab, DG NCCB, for his knowledge enriched words on this occasion. Mahapatra Sahab तो मतलब he is very energetic and वो तो पहले से हमारे साथ है, हमारे कमेटी के चेयरमैन भी है सीमेंट कमेटी के। तो whenever we are having meeting, he has very good insights in all of this. तो एक well known personality है, सब लोग जानते हैं in the cement sector, and his contribution to the industry through research project publications, intellectual interaction for a longer period of time. And recently, I would like to also congratulate him on receipt of Lifetime Achievement Award, जो 22 तारीख को साहब को दिया जाएगा। वो मैं आग्रह करूँगा कि आप लोग दिल्ली में है, अगर आना चाहे तो अच्छी बात है, लेकिन अगर वही लाइव फीड होगा तो साहब को हम अभी से कॉन्ग्रेचुलेट करते हैं. एंड आई वुड लाइक टू थैंक वाइस चांसलर त्रिपाठी साहब Satna. His visionary leadership has taken this insight to a new height. I was really surprised and very good to know that cement technology as a separate course has been taught here, which is very good. त्रिपाठी साहब, मैं आपको बताना चाहूँगा कि जैसे इंडस्ट्रियल एफिशिएंसी में रिसर्च प्रोजेक्ट्स कुछ चलते हैं तो बेसिकली हमको पता नहीं होता है, लेकिन आईआईटी रुड़की मैं नाम इसलिए ले रहा हूँ क्योंकि उनकी तरफ से हमको लगभग 4-5 प्रपोजल्स आए हुए हैं. प्रॉब्लम ये होता है कि इंडस्ट्रीज़ में कुछ रिसर्च चल रहा है बेसिकली, खास करके पैट इंडस्ट्रीज़ में, 13 इंडस्ट्रीज़ में. तो कई लोग सेल्फ इंटरेस्ट लेके ये रिसर्च करते हैं, लेकिन हमें पता नहीं चलता है. फॉर्चुनेटली किसी ने रेफ़र किया कि वह आईआईटी रुड़की कुछ स्टील को लेके रिसर्च कर रहा है. तो मैं मतलब आई वुड रिक्वेस्ट कि ऐसे यूनिवर्सिटीज़ पे जहाँ रिसर्च चल रहा है, जैसे AKS यूनिवर्सिटी है जहाँ PhD स्कॉलर्स भी है, उन लोग रिसर्च कर रहे होंगे. अगर आपको लगता है कि भाई रिसर्च हम लोग कर रहे हैं और फाइनेंस नहीं मिल रहा है, तो we will be fully funding that. You please take this word. But of course this will be relevant, this should be relevant to the PAT industries and the associated research areas. That is the condition. So अगर आपके पास रिसर्च चल रहा है, we have also proposed that not only IITs but we will be also inviting private universities to come up with these research projects so that we can independently work especially on this R&D. It would be my pleasure to thank to Dr. Srivardhan, Dr. Harshvardhan Sahab, Pro Vice VC, Satna on the dais. He has been named a member of the task force constituted by the government of Madhya Pradesh for the implementation of new education policy 2020 announced by the government of India. I also thank Bhaskar Bhattacharya, President Satna Works, who has also held several positions in cement plant, in Prism Cement and Reliance Cement. And it would be my pleasure to thank Mishra Saab, Director Cement Technology Satna Cement also. And he is an ex-technocrat and has served as additional director formerly with NCCB. I also convey DGB, our Bakare Saab, for his constant guidance to propagate the energy efficiency culture among the industries and related sectors. And he has paved a bright way to energy concise culture through various schemes in BE, and of course PAT is one of them. अगर हम लोग कोशिश करते तो सर शायद वो वर्चुअली भी ज्वाइन कर जाते, लेकिन हमारा दूसरा एक कॉन्क्लेव चल रहा है, आंगन करके एक बिल्डिंग है एनर्जी एफिशिएंसी को, तो वो ज्वाइन नहीं कर पाए, वरना ऐसे सेमिनार में तो वो ऑफ कोर्स वो करते हैं. एंड I feel proud and thankful for making this event a successful one. An event of this dimension cannot happen overnight. इसकी जो तैयारी है, the wheels start rolling weeks in advance. So we are very fortunate enough to be backed by a team of very motivated team like Kalra Saab hai, and the organizing committee of AKS University. Ankur Mittal is of course always there. And I am very much thankful to Ministry of Power and DPIIT. And thanks to you for all making this event successful. Have a wonderful interaction. और जैसे भास्कर भट्टाचार्य साहब ने कहा कि अगर कोई भी सवाल हो तो प्लीज़ पूछिए. हमारे स्पेशलाइज्ड सीमेंट एक्सपर्ट कालरा साहब यहाँ है, सो वो जवाब देंगे. अनफॉर्चुनेटली हमारा दूसरा एक सेक्टर एक्सपर्ट जो है वो इस सारे सीमेंट प्लांट को वो मालूम है, विवेक नेगी, वो ज्वाइन नहीं कर पाए. तो आई थिंक यू विल हैव अ वंडरफुल इंटरेक्शन एंड फ्रूटफुल डिस्कशंस टू बी हेल्ड. Thank you and Jai Hind.
Thank you, sir. Now it's time for memento presentation. Just AKS University and organizing team would like to present some memories in the form of mementos. And in this sequence, firstly, I request Pro Vice Chancellor Development, Dr. Harshvardhan sir, to present the memento to Dr. B.N. Mahapatra, Director General, National Council for Cement and Building Materials. Students, please coordinate for the same.
NCB का है और वो वाला memento भी चलेगा.
The memento is given by NCBM. All the mementos are sponsored and given by NCBM. On the behalf of
Last में AKS University.
I am requesting Honorable Vice Chancellor AKS University Satna to present the memento to Shri Sunil Khandare ji, Director, Bureau of Energy Efficiency. I request Director Cement Technology, AKS University Satna, to present the memento to Sri Bhaskar Bhattacharya, President Satna Cement Works, MP Birla Group. I request Engineer R.K. Srivastav, Administrator Engineering, to present the memento to Honorable Vice Chancellor, AKS University Satna, Dr. R.S. Tripathi, sir. I request Dr. S.K. Jha, Head of Department Cement Technology, to present memento to Pro Vice Chancellor Development, AKS University Satna, Dr. Harshvardhan, sir. I request Rohit Umar sir, Faculty of Cement Technology Department, to present the memento to Professor G.C. Mishra sir.
और एक ये जो व्यवहार साहब का ये 21 का जो होगा वो देगा.
To present the memento to Director Cement Technology, Professor G.C. Mishra sir. AKS University Satna also would like to honoring our guest by presenting the Ganpati ji. In this sequence, I would like to request Dr. Bipin Vyavhar sir to present the memento to Ganpati to Dr. B.N. Mahapatra, Director General, National Council for Cement and Building Materials. I request Shri Pradeep Pathak sir, Faculty of Cement Technology Department, to presenting the Ganpati ji to Sunil Khandare, Director, Mr. Sunil Khandare, Director, Bureau of Energy Efficiency. Thank you all. Thank you, sir. And organizing team is very thankful to all the honorable dignitaries and guests sitting on the dais, university authorities and dean, director and head of department, and all the faculty members of universities and different guests coming from renowned cement industries and educational organizations.
सर हो गया ठीक है अरे हो गया आप गाइस करो
We are very thankful and feel proud to have you all here for this seminar. And before National Anthem, I have some important announcement. And I would like to announce the registration card and registration kits are ready in registration counter. Please collect this after this session. And the speaker who are going to present their valuable speech, please contact to IT team for submitting their presentations. And after this session, would like to invite you all for the high tea. Now, it's a time for closing the valedictory section. And I would like to invite you all for national anthem. Savdhan! Thank you all for presenting here. And now I would like to invite you all for high tea. Please have a high tea in C11 hall. Thank you all. Have a nice day. And after high tea, we will gather again in this auditorium for technical sessions. Thank you.
Are preheater and the cooler. So preheater, if we can design in such a way that pressure drop comes very less, so that we can save preheater fan power up to 2 to 3 units. So there are plants which are operating below 400 mmWg at preheater fan inlet pressure. So this trend are going to become in next decades or next year of time. Substitution of fossil fuel with AFR up to maximum extent, installation of WHRS with maximum potential, substitution of traditional raw materials with alternative raw materials, LC3 and clay calcination. As Dr. Mahapatra was telling that industry is working for that, and so far clay calcination license is not given by the BIS, but it is expected that by this coming April or May, this will be granted. So definitely all cement manufacturers will be start working on clay calcination part and LC3 cement, because in that case clinker uses will be hardly 30 to 35%, and rest of will be calcined clay and the limestone. Next is uses of Oxy Fuel and CCUS concepts. As Mahapatra ji was telling that this is really things are moving. Our as a technology partner, KSD is also working on that. Our CTO, Mr. Matthias Marsman, is a member of ECRA. ECRA is a European Union for doing this advancement. So they are working, and definitely it is a costly method, because when we are doing CCUS or we are separating oxygen out of nitrogen, we are separating it, it costs very much higher power. So that is the challenges. Next is digitalization of cement manufacturing, optimization and maintenance package. Nowadays it is a era of IT. Everyone wants that everything will be done in automatic and there should not be more manual interference. So this is also a part which is going to be done in next coming say 20 to 30 years in cement industry. So here I would like to discuss that as a technology partner, what KSD has done. So there will be definitely some work behind if we are discussing that preheater pressure drop is reduced to say 40 mbar at fan inlet, which was earlier say 60 or 55 mbar. So how the 15 or 20 mbar has reduced. So what is done, we can see there are three photographs. We can see old cyclone, and there was one HE cyclone, and this is HE. So in this old cyclone, if you can see the dip tube and the inlet section was hardly 50 to 55%. But later on, this area is enlarged and the spiral area is enlarged, dip tube enlarged. So this way, and there was some also geometrical changes, like in cylindrical part is increased from earlier cyclones. So by doing this, all the geometry, if you can see, the height of cyclone is almost same, but the pressure drop and the efficiency has improved. So these kind of developments are continuous. So what are the steps done? As already I discussed, so apart from cyclones, the Calciner dimensions also has been changed. Earlier the velocity profile were maintaining 16 to 18 meter per second, but nowadays 10 to 12 meter per second is sufficient for these preheaters. So because of this, also there was one part at kiln orifice, kiln inlet orifice, the velocity norms were 20 to 24 meter per second. It is still in whole sim, but many of plants, they have improved it and they are maintaining 18 to 20 meter per second. Also TAD design has improved. So because all of these efforts, the pressure drop has removed from 55 mbar to 40 mbar at preheater fan inlet. We can see TAD is going smoothly and it is connected to the Calciner inlet without any bend or without any dust settling chamber or this thing. So because of this also we got the improvement, and these are the new design. So because of all this, sorry. May you please skip? Yeah, one more slide, please. Yeah. So if we see this is the live example of running plant. So if we see here highlighted the pressure, this is 400 mmWg at cyclone outlet, and this is 5-stage preheater. But this is along with WHRS. WHRS system is on. And with this, we get the pressure of say 450 or 480 mmWg at fan inlet. So next, coming to AFR uses. So where we can use the AFR? One is that if we have enough sufficient time in calciner, we can burn it and we can use around 20 to 25% of total calciner substitution in AFR. But if we want to use more substitution in calciner, then we have to connect to one call it combustion chamber, where we can provide some more retention time to it. And with this, along with combustion chamber, we can utilize around 60% substitution of calciner fuel. If we have some constraint to install this, we can install one incinerator also, so that we can increase some AFR uses, say 10 to 15% in this. And if we have plenty of AFR available, continuous supply, and we do not want to process it and we want to feed as it is, then we can use a pyro rotor, which is a new concept being developed by KSD, and almost 12 references are already operational in throughout the world. So in this, we will see later slides that it need not to process too much it need not to process too much of AFR, and AFR can directly be fed into this kind of reactor. Kindly skip the slide. Yeah. So this is newest technology. Consistently, this is we can say is baby kiln. Baby kiln is installed at the preheater riser duct, where we can fed the AFR from here and tertiary air from this duct. So tertiary air duct, which is having a temperature of 800 or 900 degrees, it starts giving burning to the AFR. Here we can see there is separate chute to feed a whole tire. Whole tire is coming through this chute, and fine AFR is being fed from here. There will be some part of raw mill dust also to control the temperature. This kiln is revolving, and this heat is getting exchanged, and this heat is going to be in kiln riser duct, where it is going to the calciner. So it is very simple reactor and need not to process too much of AF fuel. But the limitation in Indian concern is that continuous supply of this AF is important. Otherwise, if we install such a huge machinery and we do not have the continuous AFR supply, then it becomes inviable. So if this one ensure, definitely this is very helpful in case of uses of AFR. So where this technology is being used, the maximum retention of calciner fuel is 85%. 85% calciner fuel is replaced. So if you work in totality, so definitely 60 to 70% total fuel is being replaced by this reactor. Next slide, sir. Here, what are the sizes can be fed into pyro rotor? Maximum biomass 100 into 15 mm. Plastics can be fed 300 by 100 into 100. RDF or fluff can be fed 300 by 300. This is 2D dimension. Tire chips can be fed 300 by 300 into 25. And whole tires also can be fed into this. Next slide, please. No, previous one. Yeah. So this is a working principle. Here we can see oxygen enriched gases coming from the tertiary air is entering to the pyro rotor. Pyro rotor is rotating here, and from here fuel is being fed. So this fuel is getting fired inside this rotating pyro rotor, and the hot gases is being taken into the calciner. So this is simple arrangement which can be fit into existing plants also, but while considering new installation, that also can be seen. Next slide, please. Yeah, thanks. So this is concept for a new kiln burner. Here pyrojet burner is one of pioneer burner in cement industry, as we know. So here we can see there are additional ports are given. One is for gas pilot burner and gas ignition burner. For here we can feed hydrogen also, and one is here oxygen injection. Apart from oxygen, we can feed liquid fuel nozzle also. How oxygen can be fed here? Because nowadays Oxy Fuel concept is coming. So whenever we feed difficult burn materials from the burner, if we inject oxygen, definitely it is going to help to maintain the combustion of these difficult burning fuels. So this burner may be helpful when we are thinking to use the difficult burning fuels. Next comes, next slide please. Hydrogen burner development. So industry is discussing for lowest emission level, and in this scenario hydrogen burner can help, but there will be also limitation, because if we are using hydrogen too much, definitely there will be water quantity inside the flue gases, so that will be definitely a limitation. But in combination of hydrogen and other gases, it can be used. So here we can see there is a strong flame, but this is a very short flame. We required moderate flame for a cement kiln operation. So definitely we have to mix some gases, like we can mix CO2 or oxygen from atmospheric. So this way this flame length is being modulated. Next comes as a clay calciner. This is also new technology which is being discussed in India as well as in abroad. So in this we know that metakaolin, which is available plenty of places in clay, that if it is calcined up to the certain temperature, it develops a hydraulic property and it gives us strength as good as a clinker. So this is a concept, but what is the plus point in this clay calcination? That clay calcination doesn't require clinkering temperature 1450 or 1500. Clay calcination can be done between 750 to 900 degrees. At this temperature, clay develops hydraulic properties, and when it is mixed with clinker, it gives the same strength. So that's why this is being discussed here. So flash tube calciner is being used. Why rotary kiln is not used? Because if we use a rotary kiln and temperature is high, then this clay can be start fusing, and once it is start fusing, it will lose the hydraulic properties and we may not give the strength of this. So this is also a concept from KSD. Next slide please. This is a clay calciner process overview. We can see here we have a hammer mill where we fed the clay. Clay is coming, getting grinded here by the hammer mill and is being lifted. There will be a separator separates, and this clay, which is fine in powder nature, it is being fed into this drying and calcination plant, same like SP preheater. So from here it is being fed into the calciner, and after calciner it is being taken to the cooler. Cooler is not but only cyclones, it is being cooled between in the hanging ducts. So from cooler it is being taken to the silos. Next slide please. So this is just an explanation that this is the calcination tower. From here hot gases are coming. These hot gases has to be further heated by the hot gas generator and maintain the temperature of 900 or 750 as per the case. Then it is going as I discussed before. Next slide. This is the calcination part for this clay calcination. Yeah, thanks. So in this, what is the main thing here, that if we use the calcined clay, the main challenge come as the color of the cement. So like earlier, calcined clay bricks were used, but the cement color was getting reddish or it was brown. But when we are burning this clay or we are calcining the clay in reducing conditions, the color of calcined clay will be black, so it will not impact the cement color also. Next slide, please. Yeah, so these are the parts. This is the hammer mill where the clay is getting grinded. So material is being fed here, it is grinded here, and it is hot gases are coming from the hot gas generator, and it is being taken into the separation system. Next comes uses of Oxy Fuels. So it is in discussion with many of cement producer in the world. So first of all, European countries and foreign countries, it is being discussed. But in India, it is under discussion, but it may take some time. So this is just a concept how to use this Oxy Fuels. So there is one way that we first separate the flue gases which are coming from the preheater, and we separate the CO2 and we use the pure oxygen into the recuperation zone, and for the rest of cooling zone we can use the ambient air. So this way it can be maintained, but there will be always pros and cons for everything. So if we design the total ducts and preheaters accordingly to the pure oxygen, if suppose this pure oxygen is not available, then this plant cannot be run. So this is also one negative part. Second negative part is the power to separate this CO2 and oxygen is high. But definitely industry is working on it, and there will be some solution which will be given. So here I written, due to usage of pure oxygen, the specific air at preheater reduces. Normally in preheater we are using 1.4 nm³ per kg of clinker, but when we use only oxygen, the requirement of flue gases may be 0.8 to 0.9 nm³ per kg of clinker. But at that airflow, we have to see also the suspension and the flow of this material. So these all are still in laboratory trials, not yet any industrial experience have come, but definitely in next coming of time this will be done by the industry. Next slide, please. So here also this is a CCUS, Oxy Fuel plants. So this is carbon capturing and uses. So this is a different concept. Here we have air separation unit. It can be PSA. Earlier PSA was not known, but during COVID, I think everyone have know that what is the PSA when we know about the oxygen concentrator and these all things. So PSA nothing but it is compressed air, and from this air nitrogen is absorbed and pure oxygen comes to the circuit. Here also we take this oxygen into the recuperation zone or burning, and also one part is taken into the calciner. So from this whole process works, but the plus point of it is that nitrogen is separated before, so we get the oxygen level around 90%. So 90% oxygen can be directly used in the steel plant, and there will be direct consumer of it. So this is still on work. So once this is being done for industrial trial, definitely it will be very helpful. Next slide, please. Sandar. Yeah. So next, now we discuss about the cogeneration in pyro process, that what are the concept and how to use them. So I will discuss that what are the pros and cons when we are discussing for cogeneration, what are the points to be considered. When we discuss about 5-stage and 6-stage preheater system, we see that the heat of formation is same, but the exhaust gas heat from the preheater only different. So out of this total heat, whatever is given, so total power input is given as 224 megawatt, but power use in clinkerization is only half, 119 megawatt. So 105 is lost. Out of it, yeah, I will shortly cover in within 2 minutes. Thanks. So out of this, 70 to 75 megawatt is available for generation. But if we see, there is also requirement for drying of the raw material. So because of this, we cannot take all this heat for power generation. So out of it, 6 to 8 megawatt cogeneration is easily possible for the 6000 TPD plant. So traditional heat input parameters, there were very less power availability because it was not using any hot air recirculation or this kind of concept. But nowadays, it is very much feasible. Here is the concept for waste heat recovery. We can see. Please skip a slide. Yeah, one more. Yeah. So here we can see that this is waste heat recovery system. It is connected with AQC boiler. From AQC boiler, the heat is taken to power generation. And this is the preheater boiler. From here also the heat comes. But next, what is the new concept that this gases from ESP is being taken as a recirculation. So this increases the power generation. Next slide, please. So this is a KSD cooler which is installed in one of our plant where we use the intermediate crusher. So sometimes intermediate crusher is helpful to take the heat from the clinker which were going in part of coating pieces or big lump forms. So it also helps in increasing waste heat recovery. Next slide, please. Yeah, so this is concept. This is the old concept which was used for waste heat recovery system. But in new concept, it is taken as a hot gas circulation, but some part is going to the ESP to control the hood drop. But one more concept is why not we total use the recirculation. But there will be one negative thing that in case of plant trip or anything happens, then it will be difficult to control the hood drop and whole plant has to be stopped. So this is negative part of this. Next. This is one example of 9000 TPD where preheater generation is around 6 to 6.5 megawatt and 9 megawatt is coming from the cooler. So total generation is coming around 15.3 megawatt. Next slide, please. Yeah, so here is 9300 TPD, 15.3 megawatt generation is possible. So next slide. Next slide. Yeah. So one thing is that while discussing about WHRS, there should be care to be taken. As I mentioned here, correct moisture for raw mill drying to be taken, avoid margin over margin. Potential for waste heat generation to be assessed accurately and no huge margin to be kept. Tapping of mid-air is very important because if we take the tapping from mid-air and we cannot, if we not design the waste heat turbine accordingly, then it may be issue and we may lose some heat out of it or we may not be run the plant properly. Next. This is example of taking a waste heat mid-air tapping. Okay, now next final. Please make it final. I will go to conclusion. So conclusion is each unit generated by cogeneration is equal to save 1 unit. Hence, by generating 30 to 37 units, clinker means one step to close clinkerization power. Preheater pressure drop at preheater exit, we have to try to reduce while designing the plant itself so that it should be below 40 MBAR. Areas like Nepal where load restriction takes place or power cost increase during the peak hours and an interpreted operation with lower power cost is most important. And that area, it may be also that it is possible that they may get the payback period of 1.5 years installing the WHRS. To mitigate the emission of greenhouse gases which are affecting the environment adversely, cogeneration is helping. And uses of AFR definitely is going to be demand of the industry. Thanks. So I stop my presentation here. Thanks. Thanks. Thank you, sir.
Thank you, sir, for
वो कौन सा है इसका आना चाहिए अभी डिस्प्ले प्रॉपर्टी नहीं उधर नहीं कनेक्ट हो रहा है डिस्प्ले सेटिंग नहीं उठा रहा नहीं ये केबल किधर कनेक्ट हो गया उधर सेलेक्ट करना पड़ेगा नहीं उधर है उधर है सेलेक्ट है उधर केबल में प्रॉब्लम एक मिनट केबल में प्रॉब्लम देख लेता हूँ 2 मिनट भैया कुछ नहीं करो बस डोंट डिस्टर्ब एनीथिंग I will take care. Good afternoon, ladies and gentlemen. And energy is life now. So as the many speakers were speaking, the importance of the energy, I would like to throw some importance of engineers. So our soldiers in the border are saving our country. As an engineer, what we can do also patriotism by showing lesser energy consumption. So that is our motto, clean motto. So I am very proud to be an engineer to save our resources for our children. So that is our main motto. This is my Soundararaj. I am from IKN. By the name IKN, everybody knows that it is synonym for clinker cooling. So we are into the industry since last 35 years, into the best clinker cooling technologies provided as a provider. So like now I would like to take importantly talking about how to increase the AQC boiler inlet temperature for the WHRS generation without sacrificing the recuperation efficiency. So let me go into the topic. So if you look into the heat distribution of a conventional cooler versus efficient cooler heat distribution, you can see here in a conventional cooler, you will have a 65% efficiency, and you have enough potential for the WHRS system. 24% of heat energy available. For example, like 29.6 megawatt thermal energy is available for taking heat into the WHR. So what happens in case of an efficient cooler? So the purpose of having efficient cooler is to recuperate the best heat available for the combustion process to save the coal. And the WHRS energy system concept is to recover the waste heat available after saving the coal. So now when you install an efficient cooler, then naturally your WHR potential will come down. How to take care of this effect? I want to have a cake and also eat it too. I don't want to compromise in either way. Both I need energy. In both sides I need energy. So if you look into this conventional cooler heat distribution system, the mid heat of 24% is simply can be utilized in the WHRS. So the next slide, please. To increase the WHRS potential while improving the recuperation, what is the solution available? Which is a hot air recirculation concept. What is that hot air recirculation? A typical IKN pendulum cooler view you can see in the first picture, which is normal WHRS system is connected, which is recuperating a best way in a 75% efficiency, and also it is giving some heat to WHR. Now to increase the WHRS potential, some tapping can be taken from the cooler stack, and which is going as a waste stack after the WHRS utilization. After WHRS utilization, you will have almost 100 to 120 degree temperature at stack. We don't want to waste that heat and take back again and give it to the selective cooling fans. When you are giving a selective cooling fans this hot air, it will improve your mid-air temperature. Next, please. The benefits of the recirculation is that higher mid-air temperature at the same flow, there is more heat into the boiler, and a closed energetic system, you are not losing energy either where in the gas circuit. Actually energy can neither be created nor be destroyed. We have to use one form of energy to the another form of energy. So whatever the energy available, we are trying to use into the system to have a better recuperation and also have a better heat transfer into the WHR. So with this facility, what is the benefit? When the capacity goes up, the benefit is increasing, keep on increasing. So which is, you can see the potential of increasing the WHRS from 10 to 15% by using this hot air recirculation concept. How full recirculation is successful with IKN pendulum cooler? So why it was not done in the past? The reason is there was a coolers which is having rollers, bearings, hydraulic cylinders inside the compartment. To drive the cooler, you need the drive system and lubrication system, everything, which was inside the cooling compartment. Whereas in IKN design, there is no rollers, no bearings, no hydraulic cylinders, no rubber oil hoses and oil pipes inside the cooling chambers. All are located outside. If you look into this, the complete cylinder drive system is located outside the cooler. So there is no fire hazards when you are giving hot air up to 120 degrees. All you need to do is you have to select the cooling fans and you have to upgrade those fans for the high temperature operation and give the hot air recirculation to all the cooling chambers. That means you can operate zero vent. So what is the advantage of doing this in a statistical way? Yeah, IKN pendulum cooler without recirculation is in a best to recuperating condition is 75% efficiency, and vent losses are only 4%. And clinker losses are 5%. If you look at the IKN cooler with recirculation, what happens? Still your efficiency is 75%. You are not sacrificing on recuperation efficiency to improve the WHR. And vent loss is also same. And we are taking back the heat available in the boiler, after the boiler circuit. 11% we are bringing back as a heat input to the cooler. By doing this, your clinker losses are increasing slightly because you are giving hot air for cooling the clinker. So 1% clinker temperature goes up. That means 10 to 15 degree goes up. No, previous slide. Previous slide, please. And the mid loss without recirculating cooler is almost 16%. That is 22 megawatt thermal energy available for boiler. And by recirculating this hot air, your megawatt thermal energy is going to 31 megawatt as an input to the boiler, and your heat energy is increasing almost 10% in this case. So next, please. Next, please. No, forward. Next slides. Now you're going back, reverse nature. So current status in the cement industry are like lower efficiency, but good WHRS performance at a cost of lower cooler efficiency. but there is a potential loss in the recuperation. So higher clinker temperature, which is also a loss to both for a kiln and also for the WHRS system. If your clinker temperature is 200 degree plus, that energy is going waste and it is also disturbing your cement grinding system. You can extract those heat also with a better cooler and improve your WHRS system. And higher power consumption and higher maintenance cost. How to counteract this challenge? To conquer these challenges, again having a basic fundamentals. To counteract the lower efficiency, new grade design geared for higher efficiency, and to counteract high clinker temperature, it needs a new grade design to reduce the temperature at the same loading, and higher power consumption with a better gap management, higher precision to reduce the power and unwanted pressure. High pressure because of the protective layer and regulators, which can be avoided with a better design, with a better gap management statistics. So maintenance costs, a new grade design able to, with the gap management and very hard blades to reduce the wear. So the challenges on the left side can be addressed with this basic fundamental concepts. Next slide, please. So IKN strong fundamentals to counteract these challenges. KITS, clinker inlet distribution system, and Konda effect, which is pneumatic transport effect, which gives uniform aeration for the entire grade surface, and LPS with a linear pendulum suspension, which is helping you to avoid roller supported bearings, roller supported grades. And with the case studies, I would like to go to JK Lakshmi, how this was done. JK Lakshmi is having 3 kiln lines in the Sirohi plant, and which was having each line 1 capacity of 4,500 and line 2 is 5,000 TPD and line 3 is also 5,000 TPD. All the 3 lines are supplied with the IKN cooler. Now IKN cooler is running efficiently over there. They have a WHRS system plan. When they installed a WHRS system in around 2012, what they were asking for, that how to improve the WHRS system. My potential is low compared to the other plants which is running in the same capacity. To increase the WHRS system, what IKN suggested is the first time in India, we have given hot air recirculation concept in this plant. By that way, they were able to increase almost 12% of their megawatt generation. That's for 4,500 TPD, it was almost 0.4 to 0.5 megawatt, it has gone up. So with that basic things done in India, and their plant won a best award from the CIA, Confederation of Indian Industries, and this news was spreading to the market. So then everybody wanted to do. So when you have an efficient cooler, you can do this. Now it means it is proven WHRS system which was installed for the old conventional cooler, which is giving a better benefit than an efficient cooler, also can be upgraded with a new latest generation cooler like IKN cooler and improve the efficiency and also increase the WHRS generation. Next slide, please. So what happened in this JK Lakshmi, almost 0.5 megawatt has increased. And next slide. So JK Cement Nimbara, in this case, they saw the performance of hot air recirculation at JK Lakshmi. They are running within a conventional cooler with a 60% efficiency with a very good WHRS generation. Whereas they want to improve their heat consumption by 50 kilocalories from 770 to 720. Now the problem is my system of WHRS is already designed, which is operating. When I improve the heat consumption by 50 kilocalorie, you will definitely suffer at a WHRS generation. What is the solution? Then they came to IKN. We have given a solution with hybrid aeration. It means with we can give a hot air recirculation for this case also by upgrading the clinker cooler with IKN. What we have done is here, again the same tapping at ESP outlet, ESP fan inlet, and there is a fresh air damper also provided here to take care of emergency situation. And this entire duct is going into the cooler building, and these are connected to the almost 5 cooling fans. It means this plant can operate with almost nil emission. There was an emission problem also because of the ESPs, and the ESP was been further upgraded. But after IKN, the emissions almost came down to nil. So your environmental emissions also came down because of the 100% hot air recirculation in this plant. So what are the benefits they got? Next slide, please. So initially with the second generation cooler, hybrid cooler it was, they had a 6 megawatt generation from the cooler, line 3 alone. And the cooler efficiency was 60%, and later the production was only 4,500 tons. By changing the cooler along with the burner from the KHT, they have increased the production by 4,000 tons, 4,500 to 5,050 tons, which is almost 440 tons increment. The heat consumption has come down by 50 kilocalories, and the cooler losses 37 kilocalories. With the help of burner also, and also the fuel feeding system, they are able to reach 50 kilocalories easily. So how the WHRS performance also increased from 6 megawatt to 7.2 megawatt. It is a win-win situation. So it increased in both sides, recuperation also and WHRS also. Then this system become much proven for even for a conventional cooler upgrade also. Later, if you look into this, next slide, there are various other references that have come to India from IKN cooler. Like 4,900 TPD at Rajasthan, 5,000 TPD, again Rajasthan, 8,000 TPD. From 4,500 to 10,000 TPD, we have various references. And now all the new plants coming with, whatever the new plants are being supplied, they are choosing an IKN cooler for efficient operation, along with the hot air recirculation, with 100% hot air recirculation capacity. It means you can recirculate everything, your stack will be almost nil, maybe 0.1 nm cube, which is going only to control the hood draft. Please, next slide, please. Next slide, please. So limitless WHRS generation. Now we are talking about the fuel cost is going 3 times than last couple of years. So now the fuel, saving the fuel is very much essential. Whereas, if you look into this animation, click. So what I was trying to show here is the energy can neither be created nor be destroyed. But when your fuel cost is becoming negative, now people are thinking about using alternate fuel and substituting the TSR rate up to 70%, 80%. In maybe next 10 years, we will be reaching more than this. What will you do at that time? So you can operate the efficient cooler, and you can burn one of the plants. Next slide, please. One of the plant in Europe, when we went, IKN cooler was supplied at 75%, and they were operating at 60%. They were taken additional tapping inside the recuperation zone and giving to WHRS and giving more than 600 degrees to the boiler, or 700 degrees also, which is possible. Then we asked why you are doing this. Because I am getting money by burning fuel, and why I should lose this. So I am burning more fuel and getting money, and generating more power from the efficient cooler and generating money. In either way I can generate money. This is a limitless WHRS generation potential available from the cooler. So this is how IKN has got in both cases, both efficient mode operation and also inefficient mode operation according to your requirement. In both cases, your clinker temperature will be on lower side. With the efficient cooling, your clinker will be on lower side. The heat available above the clinker bed surface can be utilized. Either way, it depends on your requirement. So thank you very much. And next slide, please. IKN has set various benchmarks on this. Next slide, please. Always set a benchmark like lowest normalized cooler losses, 85 kilocalories, and lowest power consumption, 3 kilowatt hour per ton without HAR, and lowest maintenance cost and highest power generation in WHRS with a hot air recirculation, almost 1.5 megawatt increase in a 10,000 TPD plant. Next, please. And thank you very much for your kind attention. And if you have any question, please request. I'm ready to answer. Thank you.
Participants, you keep your question ready in the question answer session. We'll discuss in that.
So we have to place this very heat transfer equipment at very optimum for optimum heat recovery system. We have developed one program for calculating this heating surfaces as well as temperature profile. So it will give maximum waste heat recovery from the system. Next.
After that, the gas distribution on this various heating surfaces of the boiler is very important. For that, computational fluid dynamics is a very good solution to make it optimize heating waste heat recovery system. So in that, we can predict the actual gas flow over the heating surfaces. So in this, we can see this one horizontal type pH boiler earlier. First, previous slide. This. Okay, this is CFD analysis for pH boiler, horizontal pH boiler. In this, if you see the first picture, in that there is a gas distribution, there is some problem. So gas is not distributing, and velocity of the flue gas over a heating surface is not proper. So there is it's give not maximum efficiency of heat recovery system, and that's why computational fluid dynamics we are doing for this kind of waste heat recovery system. And this after this analysis of the system, if you see the below picture, in that we have done some baffling arrangement in a hopper and in superheater zone as well as evaporator zone. So it will give best gas distribution and uniform velocity over the heating surfaces. So it gives a maximum utilization of the heat, as well as there is a minimum heating surface required to generate the steam. So it will give economical solution also. So this is very important in designing of the waste heat recovery boilers in a preheater area and crinkle cooler area also, AQC boiler also. Next. This is one ESP model. We are a manufacturer of ESP also, so we are supplying ESP. So in that also we are doing the same kind of arrangements for better gas distribution and maximum ash collection in ESP. So minimum outlet emission we can achieve. This is all about the waste heat recovery optimization and design part, and we are doing some automation also. In that we can give better operation of the waste heat recovery system. In that we have developed some programs and some logics which we can build in the DCS system. We have one independent instrumentation team where we can do this activity, as well as all electrical parts also we are doing. Next slide. So this is one model of the DCS. Next. So this waste heat recovery in a cement plant, we can say, means 33% of the total energy required, electric energy required, that we can be utilized from waste heat available in a cement plant in clinker cooler as well as preheater area. So this is the distribution of waste heat recovery, and that's why we are using this waste heat recovery system in various cement plant as well as in steel plant. Next. So if we see, total heat is 90%, and electrical 35% of energy in a clinker calcination process is discharged by the waste heat, and of plant electrical energy requirement 30% we can utilize this electrical energy in our cement plant. So 33% of electrical energy we can generate by the waste heat. Next. So these are some design patterns which we have developed for the waste heat recovery boilers. First one is vertical cross flow with bare tubes in preheater area. Then horizontal cross flow, that I have just explained the CFD model of that. So here horizontal flow, and vertical cross flow with fin tube for AQC. Next slide. This vertical cross flow, bare tubes, this is again one model for a preheater. Next slide. Then vertical cross flow fin tubes for AQC. In AQC boiler, the main part is in design is pre-collection chamber. So we have developed a pre-collection chamber with a cyclone separator, which give maximum dust is collected in this hopper itself. So minimum amount of dust is going to the heating surface like a superheater and other part of the AQC boiler. So it will reduce various problems related to the dust because of its dust characteristics. So this is the one of the one feature of our AQC boiler. Next. So design consideration of waste heat recovery boiler for cement plant. So bare tube design for preheater, then rectangular fins, tubes for AQC boiler. Earlier I have shown the photograph of fins which I have developed, rectangular fin. Then hammering system for preheater boiler. For getting optimum results from the waste heat recovery boiler, this cleaning system is also very important because in preheater the characteristics of the dust is to stick the heating surface. So it will reduce the heat transfer coefficient. So after that we can over a period of time there will be a decrease in the efficiency. That's why this cleaning system is important. We are having a hammering system for various preheater boiler, as well as air blowing systems is also there, air soot blowers. And this waste heat recovery boiler we have done 3 jobs. JK Cements Rajasthan, Ultratech Cement and Ultratech Cement Ravan and Awarpur. So here actually we have done a modification of the existing waste heat recovery system. Earlier they are getting less efficiency, so less power generation is there. So we have modified the heating surfaces, we have modified the gas ducting inlet, outlet, and for better gas distribution and maximum efficiency. After that we are gaining power in as per table. It is 1.9 megawatt for JK Cement, 2.5 megawatt for Ultratech, then Ultratech Cement Ravan 5.5 megawatt. So with existing system of waste heat recovery, there is also a chance of improvement to get a maximum efficiency. So maximum utilization of waste heat can be done. This kind of jobs we have executed. Next. Then other projects in Dalmia Cements we have worked. Then Ultratech Cement Ravan we have executed earlier job, and again now second boiler we are doing this kind of modifications. Next. I will just brief about the other fuel-fired boilers because it is also one of the part in cement industry as a captive power plant. So we are a manufacturer of ABC boiler and.
Do you want to create another source of income from stock market by just spending 30 minutes a day? And that to you.
Power plant, Apollo Tire, Nepanagar, AB Grain Spirit. Then 30 megawatt captive power plant with 2 numbers 90 TPH boiler and revamping of boilers for efficiency improvement. And presently we are doing some proposals for using biomass and other waste into the captive power plant boiler. So there will be a reduction of coal consumption and operation cost of the boiler can be reduced. So in that type of modifications we are doing for captive power plants also. Next. Yeah, these are some photographs. Next. I will take 2 minutes. Our company policy is to serve better to the customer after sales also. After execution of the projects, we are serving the customers as per their requirements. And we are providing quality services in execution stage also, and we are trying to give best product to the customer. Next. Exports, we are doing exports also in boiler area. Next. Auxiliary products, we are making auxiliary products also, like ESP, we are supplying independent. Then electrical instrumentation, that also we are giving independent supply. Then balance of plant work we are also doing, and the revamping of the existing system. Next. So this is all about the Citizen India, and whatever in waste heat recovery we can, what optimization we can do, that I have explained. So if you have any question, you can ask. Thank you very much for hearing patiently.
Thank you very much, sir, for a wonderful presentation. Now, the presentation will start of Vijay Kumar Giri, sir, from SRS MES.
Sir, you can start, sir.
Can you hear me?
यस सर।
आवाज आ रही है मेरी?
जी आ रही है सर।
तो शुरू करें?
जी बिल्कुल।
शुक्रिया। Good afternoon all. This is Vijay. I'm representing SRS MES. First of all, I would like to thank the Vice Chancellor and the Director Cement Technology, AKS University, and NCCBM and VE for giving us the opportunity to present a few solutions on hot air recirculation, the case studies that we have of all the projects that we have done. Till now, you would have already heard some of the OEMs and other vendors presenting you similar solutions to you. We are not much different because the technology is not unique in nature. It's been almost been there in the industry for 40 to 50 years of hot air recirculation. What is specific is in this case related to the hot air recirculation for utilizing the waste heat for waste heat recovery. SRS MES, we are a 9-year-old company. It was started by an ex-FLS person and currently being run by people who have designed, operated and managed cement plants. So we know everything from design, engineering, projects, commissioning and operations and management. So we know the various aspects and the challenges that exist in cement plants while operating the machineries, and these problems or challenges are addressed in our designs. Waste heat recovery, it's all well known, so I don't want to spend much time on this. How do we do it? Just before a couple of presentations, they have some of the other presenters have given you an idea of still maintaining the recuperation efficiency of the cooler. We had presented this paper at one other seminar of NCCBM. So the priority per se is to keep the kiln steady and utilize only the waste heat that is available for waste heat recovery. So what we do is that we do an existing cooler heat balance without the waste heat recovery to meet the kiln requirement to the maximum capacity that is needed with the best possible efficiency. Once we do that, we establish the cooler heat balance for existing or proposed waste heat recovery. Here the challenge that comes up is that what is your null point and where exactly you need to do the takeoff, while not starving your preheater or calciner or the kiln for tertiary and secondary requirement. That is required to ensure that your kiln is not disturbed, your kiln is steady and producing the clinker of the right quality at the maximum production. Once we do that, then know what are the fans that are contributing to waste heat recovery and what fans are needed for ensuring that the clinker that is coming out of the cooler is good enough or cold enough to be meeting the requirements of your cement mills. After we do that, we do the cooler heat balance with the existing or proposed waste heat recovery with hot air recirculation. In this, when we do this study, we determine what is the excess temperatures and excess heat that will be made available to the waste heat recovery AQC boiler inlet, and whether any other fans are available for cooling the clinker. While we determining the recirculation fans, we also see what are the mechanical situation inside the cooler, whether we have to protect the bearings, the supporting structure, etc., etc. Afterwards, we propose the equipment flow sheet with clear specifications as well as a routing that is streamlined to reduce the pressure drop from taking the hot air from the cooler vent fan and back into the cooler fans. At this point, we have been installed quite a few hot air recirculation systems for our customers, and some of them are in the execution mode. Till now, our customers are saving almost 23,000 megawatt per annum in power, and there is a lot of fuel savings and a corresponding CO2 reductions. In turn, I'll present you a couple of case studies to highlight what we have proposed and what are the guarantees that we have achieved. This is for UTCL Ravan. I think some of the UTCL people should be are probably listening in the participants. This is related to Ravan. Here, what we have done is taken the cooler heat balance for a 5,600 TPD kiln, and then we had guaranteed 40 degrees centigrade and a clinker temperature not more than 20 degrees centigrade. And what we have achieved is basically higher than what our guarantees are, 41 degrees increase in the recuperation temperature and less temperature than what we had guaranteed for the clinker.
We are not able to see your slides.
And this particular Travan, we have been able to achieve 0.5 megawatt of extra generation through hot air recirculation. This is the data validated by the our client. So this was the Ravan. The fans
Vijay sir.
We have provided the hot air.
Vijay sir.
Yeah, can you hear me?
Yeah, sorry for interruption, sir, but your slide is not being seen here, sir. Can you please put in your presentation mode?
Not changing?
No, sir, it is not changing. Only the title slide is being seen here. Can you put in presentation mode, sir?
Yeah, 1 minute. Instead of presentation mode, I will, at what slide am I stuck?
Sir, it's first slide, title slide.
Okay, right. Sorry.
No, sir.
So maybe the presentation mode, right. Um, I would repeat on the basic principle. In this one, as I mentioned to you, we do the cooler heat balance.
Sir, there is no presentation, sir. Sorry, sir. But
Yeah, can you hear me?
no, actually, we can see you, sir, but presentation is not there, sir.
I'm sorry, the slide has not changed.
No, sir. Actually, no slide is there, sir.
The slide is not
We can,
changing?
yeah, we can see your face only, sir, over the screen.
You can see only my face.
Yes, sir.
That is strange. Can you?
Yes, sir.
Can you see the
Yes, sir. Now we can see the slide number means
5.
Yeah, 5. Can you please put it in presentation mode, sir, so that we can see it in a broad view?
Yeah, changing?
No, sir. Yeah, we can see the slide number 5. Okay, sir, you can just,
now,
yeah.
Do you see the change to slide number
Yes,
6?
yes, we can see. So you just click on the slide, sir, whenever you
So
present.
the presentation mode, I will put it in the this one. Sorry for the inconvenience.
Oh, no, sir. Thank you, sir.
Right. Sorry, guys, for the technical glitch. Just to repeat, first, heat recovery. The basic purpose is that the ultimate objective is to make clinker production and meet the kiln requirements. And whatever is the surplus heat, to determine that to be used for waste heat recovery. That is the basic purpose. On the second step, what we do is that we identify how much of the heat that is available for waste heat recovery from the cooler. And in this one, what is absolutely necessary is to determine where exactly is the null point for meeting the combustion air requirement for secondary air, tertiary air at the maximum kiln capacity with the minimum fuel consumption and the maximum recuperation efficiency. That is that objective cannot be changed. After this, what we do is that we determine the cooler heat balance with the proposed waste heat recovery system with hot air recirculation. In this one, we determine how much the hot air can be, temperatures to the AQC boiler can be increased, and what would be the subsequent impact in clinker temperature increase for the kiln. And here we also determine into which fans we need to recirculate the hot air. After this, we give the flow sheet and the specifications. In this particular slide, what you see is that we have left the last 2 fans without hot air recirculation, basically to ensure that the clinker temperature is cold enough to meet your cement mill temperature. This one, the hot air temperature to the fans is controlled through a bleed air damper to ensure the temperature of at the inlet of the fans is 100 plus or minus 20-25 degrees centigrade. Then we do what we also propose is a streamlined layout such that there is a minimum pressure drop from the cooler back filter exit at the fan to back into the cooling air fans. So, as I mentioned to you before, our clients where we have installed hot air recirculation systems have been saving significant amount of fuel and also reducing their CO2 emissions while saving in power. I also give you a couple of slides on what we have achieved at various places. At Ravan, we increased the temperature by almost 41 degrees centigrade, while the clinker temperature we had guaranteed will increase not more than 20, but actually the clinker temperatures were lower. So in this particular case at Ravan, the hot air recirculation was given to the last 3 fans, where clinker temperature was not a major issue, which they said they could manage. At Aditya Cements, we had guaranteed 32 degrees increase, and we had delivered 50 degrees increase in hot air temperature to the AKC boiler, and less than guaranteed clinker temperatures at the outlets. That means the efficiency were reached. The temperature and the reason why they were lower, clinker temperature lower, you could see that the hot air recirculation after we gave it, that we left 2 fans for ensuring the cooling of the clinker to meet the cement mill requirements. So in terms of a payback, obviously payback is critical to your unit heads, CMOs, industrial directors, etc. Most of the projects that are on HAR we do are giving a payback period of 1 to 1.25 years. This is not our figures. These are the figures that have been given by our clients. We did the bail-up cements also, similar. We had guaranteed 45 degrees AQC temperature increase, and we had delivered 51. Clinker temperatures were lower, almost half of what the proposed increase. And you could see the streamlined layout of the ducting from the cooler vent back to the fans. This is the Bela cement. In this particular case, you could see that the hot air recirculation has been given to 4 fans, and they are split. And in between, you see a cold air fan. Here we have left that particular fan for ensuring that the bearings and the supporting and the drive arrangements of the cooler is protected. For that reason, we have split the hot air recirculation between the 4 fans with the intermediary having a cooler fans. So again, in case of Baylor, the payback period is 1.1 years. We have quite a few projects ongoing. We are doing at Dalla. We are doing the complete engineering, including the cooler fans, controls, expand, and all the total system guarantee. In Dalla, we are doing hot air recirculation for 1 fan. The expected benefit is slightly lower because the capacity is lower. 35 degrees centigrade increase in clinker temperature, in hot air temperature increase, and 15 degrees increase in temperature. This is under execution. Then we are doing Rajashri Cement Line 2. Here, it's a 30 degrees increase in temperature, 0.3 megawatt is the extra generation, and 15 degrees is the cooler. We are doing line 3 for Rajashri. Again, here we are delivering 0.45 megawatt of extra power while increasing the temperature by 35 degrees and ensuring that the clinker temperature doesn't increase more than 15 degrees centigrade. So we have quite a few other projects that are in the pipeline. We are doing hot air recirculation for all the major OEMs, KHD, Policius, IKN, Fonds, etc. And the project that we are covering meet the kiln capacities anywhere between 2,500 to 11,000. They are under various stages of technical discussions and finalization. So we do the complete concept finalizing, process design, detailed engineering, and etc. We do the process to ensure the baseline data is fixed. We started with a cooler audit, followed by a proposal, and then the installation and commissioning. We also support the erection and commissioning. So that's normally in the hot air temperatures, we ensure that at the fan inlet they do not increase more than 100 plus or minus 20 degrees. Our customers are all the major cement plants in India, and we also do projects overseas, etc. If you have any questions, because we are online, you could email us. Our contact details are available. Myself and Mr. Kamesh, System Manager, we are available to answer any queries. Please drop in a line on email, any queries, or you could pass it through Mr. Professor Pathak or Mr. Mittal or anyone. Thanks a lot for giving us the opportunity, and apologies for the technical glitches which have been there in the in the online presentation. Thanks a lot.
Hello, any questions? Because it's an online presentation, if you have any question, you can ask him just now. Because connectivity is very difficult to getting. So, किसी को अभी क्वेश्चन कुछ पूछना है तो ये पूछ सकते हैं अभी. Any participant? Eureka? No?
I'll request Sharat Tripathi, sir. He had a question. Since there is a process expert online, so I'll request Sharat Tripathi, sir, to ask this question.
Sir, my question is that we have not getting...
Sir, sir, it's not audible. Can someone make it a bit louder?
Sir, my question is that midpoint temperature in cooler is not getting stable. So we are losing WHRS power generation 2 to 3 megawatt. But kiln is stable, but midpoint temperature is not stable. So what can we do?
Right, sir. This is a one. I'll just put back the presentation again. Sir, we had a similar query in other seminar recently. The basic problem of temperature control of the AQC boiler taking from the midpoint is not the problem of there are two things. One, can I go back to the slide?
Yes, sir. Actually, we can see the slides. You just click on the particular slide, sir.
I will reshare the slide and I will present you the specific problem you have expressed. Right.
Okay, sir. We can see the slide, sir.
Can you see my slide number 6?
Yes, sir. We can see.
Yeah. My answer will be a mix of English and Hindi. Basically, what you have expressed is that here I have shown only one type of mid-air type of either one, waste heat recovery in your particular plant could be 2 takeoffs, or 1 takeoff with a mid-air takeoff and 1 here. The reason this air basic requirements, this temperature is fluctuating because the cooler operation stability is fluctuating. That is the basic aspect. If the hot air recirculation is a one, I do not know if you had a hot air recirculation. If it is without hot air,
yes, sir. Actually, we have hot air recirculation.
Yeah. If you have hot air recirculation, there are 2 things. Is your hot air recirculation inlet temperature fluctuating? 100, 120 के बीच में जो है, उसकी consistency क्या है? That is number 1. Number 2, अगर टेम्परेचर में आपको ज़्यादा फ्लक्चुएशन आता है, recently last few weeks back we were discussing about tree cement where the temperature was fluctuating 150. Basically the air temperature consistency is dependent upon your cooler consistency. If your cooler stability is not there, the recuperation efficiency here, if this tertiary air and secondary air temperature are consistent, basically it is the performance of the cooler. If your tertiary air से आपके process engineer से आप एक exercise करवाइएगा, tertiary air temperature, secondary air temperature or mid air temperature or the lower tapping temperatures की trends करवाइएगा. And if the trends are fluctuating, it is bulk of the reason is your cooler stability. First, you have to ensure that your cooler is running in auto loop. All the fans are running properly in control loop properly. And the cooler grades and the cooler whatever it is, whether you have an IKN or a crossbar or whatever it is, that is the thing. Because hot air, if hot air is consistent, this fluctuation what you get in the mid-air is basically the instability of your cooler. So first fix the the kiln stability and the cooler stability, the other thing will come automatically. That is what I would say. I'm a process engineer. I've been there in the industry for 30, 40 years. So this is our analysis where we have discussed these problems with other plants who are facing this. Keep your cooler steady.
Okay, right. Thank you, sir. Thank you.
Thank you.
Any more question is there? Okay, thank you, sir. Thank you for the presentation.
Yeah,
And
sorry for the inconvenience. Right.
no, thank you. Thank you so much, sir.
After this presentation, this wonderful presentation, we have very small change in the presentation. The effective hydrojet cleaning system for the effective working of WHRS by Nitin Pathak, that will be the first presentation of the third session. And we will go for the lunch. And after lunch, we will start our second session and third session. And we are running the shortage of time. I want to conclude the session by 5 o'clock. So we have reduced the time for the presentation to 15 minutes. So all the presenter, please stick to the time so that we can conclude the session. And we will start the third session at the 3 o'clock. Pardon, sir? No, we will start the next is this second session at 2:30. The third session will be 3 o'clock. So third session will 1 hour 15 minutes. Then 45 minutes is the concluding session, and by sharp 5 o'clock we will close this seminar. Okay? So I will invite everybody. Last में sorry, sir. So another, please, another few minutes I will take. पाठक वो मोमेंटो वहां से लेकर प्लीज जा रहे हैं तो मोमेंटो I can now invite the Balesh Kumar Singh, KSD, for his wonderful presentations. As a presentation of the memento, may I invite Kalraji, please come. Can I request Khandare ji, please come to the dais. Sir. May I request Sundarraj the ICANN? And our next presentation, Nitish Yadav. Nilesh Yadav, assistant. Nilesh Yadav ji from assistant. And for Vijay Kumar, if anybody wants to receive, you can receive, or Ankur can receive and send to him. Ankur Mittal ji will receive on behalf of Vijay Kumar ji, and he will send his memento to Chennai. Thank you, Kalra sir and Khandare ji. Now the session is the first technical session is closed. 2:30. By 2:30 sharp, we have to assemble here for the session 2. So that on time by 5 we will close this technical meet. Thank you very much. You are welcome and outside for the lunch.
Then projects received through willingness form by facilitation center, then process flow on web portal, and a little bit information about the web portal. So this is the team of facilitation center. The team is being headed by Mr. Sunil Sharma, who is vice president in Darasha, and he is certified energy auditor. Then Geostat Informatics, they are IT partners who are developing IT portal for this facilitation center. Mr. Abhilak Singh, who is banking expert and he is retired from IREDA. Mr. KK Sinha, he is large industry sector expert. Mr. Vivek Agarwal, sector expert from building. Then Mr. Gitesh Goyal, he is sector expert who is looking after MSME projects. And myself, Sunita Awal, who is BD and engagement experts. And there are other colleagues also who are working on this project. So about the BE's facilitation center, BE has set up this facilitation center basically to encourage and upscale energy efficiency financing in India. The objective of this facilitation center is to collect willingness form and spread the awareness of BE's financing scheme among various beneficiaries like large industries, DCs, PAT, who comes under PAT schemes of BE, then MSME, commercial and institutional buildings, municipalities, corporations, commercial establishment, and other stakeholders like ESCOs and all. So FC has also prepared a list of technology which will be uploaded on BE's website soon. So BE has constituted a technical expert committee who meets every month to review and update the technology list prepared by FC in consultation with the experts and BEE. We are also developing online web portal for mobilizing EE financing in the country. So once this EE web portal is live, so all the willingness form will be received through this portal only, and this financing will be also moved through this web portal. Okay, so willingness form submitted online will be registered by users, and then they can fill the willingness form for energy efficiency financing. Then stakeholders can fill project related information which in the willingness form. I'll be explaining about the willingness form and the technical form in later slides. Then willingness forms will be evaluated by facilitation center, and recommendation report will be submitted to financial institutions. So right now we have on board 21 financial institutions who are on board, and they will be providing funding supports to borrowers. So FC is also coordinating with the financial support for loan disbursement status and tracking of this implementation of the EE project. So willingness form, we have prepared a small guideline generally to help the borrowers who are filling these willingness form. So this willingness form consists of two parts. That is, one is a very basic information which doesn't take more than 5 to 10 minutes. And this willingness form, part one is technical, part one is willingness form, and part two is technical details about the project. So funding support and assistance for this EE project can be applied through filling this willingness form. Right now, we are receiving willingness form offline, but once this web portal will be up and running, then borrowers or beneficiaries or agencies can fill this willingness form online, and then they can apply for the filled willingness form along with the technical detail will be evaluated. Its technical due diligence will be done by facilitation center, and then the technical evaluation report will be submitted to financial institutions for further funding process. So this is the willingness form. So part A of the willingness form is basically the very basic information about the about the entity. This where agency has to fill their address, then type of industries, then nature of projects, such as whether they wanted to procure any energy efficient appliances or technologies or equipment, then contact details of the nodal officer who will be looking after the project, what is the sector of the project, and such kind of information are sought in the willingness form. And the second part, which is there on the screen, which is at the right side of the screen, is basically the technical detail of the willingness form. So this technical detail here, the technical details related to the projects are required, such as sectors, location of the project, then details of EE measures or technologies, then baseline scenario, if any, for the project, then fuel saving, electricity saving, total project cost, then cost of EE component in the total project, then loan amount required, and status of the project. Status of the project as in at what stage the project is. It is at DPR stage, or it is at implementation stage, or it is pending for approval from the management. So these kind of information will be filled by the beneficiary when they apply for the through this facilitation center for energy efficiency project. So this willingness form doesn't take more than 10 to 15 minutes. So whoever wants to apply, they have to fill this form and submit to facilitation center. Then we have also prepared a list of technologies. As I already mentioned, that this list of technology has been prepared in consultation with technical expert committee members. B has constituted some 8-9 technical members who meets every month, and they evaluate these lists and update the list every month. So some of the technology right now, this 76 number of technologies has been finalized and approved, and this the detailed technology list can also be uploaded from the BE's website, and it has not yet uploaded, but it will be uploaded soon. And once the facilitation center's web portal is live, then this can be seen over there also. So some of the lists, some of the technologies are we have tried to consider almost covered all the sectors like electrical, thermal, and some of the technology name are automation and system control. Then cement sector we have tried to cover, building sector we have tried to cover, paper and pulp, machine tools, foundry, brass and equipment, building, grass, chemical, ceramic, refineries, etc. This list covers the parameters such as saving potential, sectors, average investment, annual monetary saving, estimated payback period, etc. So this list will help financial institutions to basically look into the EE financing projects. So because most of the financial institutions, they are not aware of energy efficiency projects, and that's how they are not in position to fund those projects. So for financial institutions we have prepared this technical e-technology list. Some of the technologies are automation and control system, combustion control for boiler, then energy management system, harmonic filters, and micro turbine. And you can see number of technologies which are listed here. This is all and we have tried to cover the sectors. We have tried to provide the range of saving potential. This is all list. We have covered the forging sector also, tea processing, ceramic, chemical, limestones, refineries, then pharmaceutical also, sponge iron, textile, bricks. So some information regarding the projects received through Facilitation Center. Till date, we have received 54 number of willingness forms from various sectors like cement, building, textile, and we have received technical details from 33 projects, and 29 projects are evaluated by Facilitation Center, out of which 25 projects are submitted to financial institutions and they are at various stage of funding. So some of the projects are under evaluation, some of the projects are there which are already under discussion with the financial institutions and borrower. So, so this is the information about the projects. So total project cost of these 54 projects are approximately 1,000 crore, which has been received by a financial institution, Facilitation Center. Till date, we have 21 banks or financial institutions on board to support funding requirement of various beneficiaries. Some of the banks which are on board are PFC, SIDBI, Tata Capital, IREDA, then IndusInd Bank, Yes Bank, Karnataka Bank, Bank of Baroda, Canara Bank, HDFC Bank, Punjab National Bank, Bank of India, Indian Bank, Exim Bank, HSBC, Seekers. We are also trying to take on board some of the MFIs who can support small projects also. So out of, so these are the state-wise segregation of the projects. So till date, we have received maximum number of projects from Andhra Pradesh. So total 54 projects are there. Then these are some of the rate of interest which are offered by various banks, which you can see on the screen. The rest of the banks they will negotiate once they decide to fund any of the EE project. In process flow for web portal. This is the process flow for web portal, wherein borrowers or beneficiary will be applying through filling of willingness form along with the technical details. They have to submit their energy audit report or DPR so that Facilitation Center can evaluate those proposals, and they can submit. They can prepare a technical due diligence report, and the same is submitted to DE as well as to Facilitation Center. Once this once this EE project is recommended projects are submitted to financial institutions, then financial institutions take these projects on one-to-one basis with these borrowers and beneficiaries. So if any project is, any of the project wanted to do their energy, do their project EE grading, they can also, the option is also there. So any banks or financial institutions for the viability or for more strong distance, they can ask any borrower to get the grading done for their project or their technology. So we have also prepared a web portal for this, which is under process right now, and it will be launched soon. So the basic details which are provided here is about the Facilitation Center, objective and overview, then list of empaneled banks or banks on board, FIs, NBFCs will be uploaded there. A dashboard will be there wherein for the public view, wherein you can see how many banks are on board, how many projects are received, how much is the potential in energy efficiency and things like that. And willingness forms you can download, you can view, you can in fact submit those willingness forms online by registering as beneficiaries. And list of energy efficiency technologies will be there. then awareness workshop, awareness about workshops, upcoming webinar, or any of the workshops which is being conducted by BWE will also be reflected on the website. News and updates from these and Facilitation Center regarding their social media can also be seen on the web portal. So this is the web portal homepage, which will look something like this. It is under process. I am just showing how does this website look like. This is still under process. So this will be the dashboard, which will look like this. You can see your energy efficient technologies, then willingness form, how many willingness forms has been received, then reports forwarded to financial institutions and banks, then how many workshops are conducted, then how many FIs are on board, and industrial customers registered so far. So these are the upcoming workshops. The website is under development, but this is just to take a feel how it looks like. And these are some of the testimonials from the various sectors. And then the B updates will be there. This is the contact page of this facilitation center. Then user login will be there. A dedicated web page is provided to financial institutions who can do.
Thank you, ma'am. Now we are moving towards our next presentation, which is on novel configurations in waste heat recovery system, presented by Mr. Ankur Mittal, NCCBM. So I would like to invite Mr. Ankur Mittal. Yes.
Good afternoon to you all. I am Ankur Mittal, working as a group manager in NCCBM. I have total 17 years of experience, and out of that I have worked 8 years in industry. I have worked for Ultratech Cement Limited. So today I am going to present over a novel WHRS technology in cement plants. The sessions we have covered till now. So we have covered that how to increase the input of waste heat recovery system, as well as how to make selection of WHRS system so that we can ensure the maximum output. So I'll not touch upon these points in this presentation. I'll keep it short, and I'll tell you that what are the other uses other than the power generation that we can explore from the waste heat recovery systems. Next slide. So this is a pattern of energy generation in our India. still the dominant factor for energy generation are thermal power plants. So to increase the availability of power, if we keep on depending over thermal power systems, then it will be difficult to meet the target. So we have to increase the contribution of other parts. Waste heat recovery system is also one of those contributions. If we increase the efficiency, if we increase the output of waste heat recovery system, so that we can cut the import of power from other sources. So this is the importance of waste heat recovery systems. Next. Next. Yeah. So this is the scenario that what is our journey for increasing the potential for waste heat recovery system. If we compare the 2017 with 2022, so we can see that there is a jump of 215% from the figure of 2017 to 2022. So in the morning session, it was also told that still there is a potential that we can explore from the waste heat recovery system. So this is the means efforts done by the cement plants to increase the capacity of waste heat recovery system in their facilities. Next. These charts are prepared to see the potential. That again depends over the flue gas temperature as well as the configuration of preheater cyclones. But we can see that whatever the technology or whatever is the input temperature, the range of waste heat recovery, it lies between 25 kilowatt hour per ton clinker to 45 kilowatt hour per ton clinker. So, and the x-axis, we can see that it is the clinker capacity tons per day. So accordingly, we can see that what is the potential that is being explored in our plant in terms of configuration and in terms of input heat that we are providing to the waste heat recovery systems. Earlier one, next. This one? Previous one. Yes. So this was about the first chart. Now in the second chart, we can see that this is between the preheater exhaust temperature and power generation potential in megawatt. So this is the clear relation that as the temperature increases as input for waste heat recovery system, the generation increases. So this is a summary that how the power generation potential depends upon the property of material. This also plays a vital role because after preheater, we use hot flue gases in the raw mill and in the coal mill. And as per the moisture contained in the raw material, the input quantity of heat to the waste heat recovery boiler, it varies. This is the comparison between two popular technologies, that is a steam Rankine cycle and organic Rankine cycle. So most of the cement plants, they are adopting the steam Rankine cycle. So this is the comparison that what parameters we should take care between making selection between steam Rankine cycle and organic Rankine cycle. So this is the difference between working fluid, equipments, part load operations, temperature sources. Here we can see the major difference is between the working fluid. In a steam Rankine cycle, while we are using water, in organic Rankine cycle, we are actually using a combination of two fluid. One is thermic fluid, that is thermal oil and being heated by the flue gases. That heat is being transferred to a organic material, and that is contributing towards power generation. So as I told you that in my presentation, I will not discuss about improvement in power generation through waste heat recovery, but I like to discuss about other possible uses that we can see from the waste heat recovery. So here we can see that in the waste heat recovery from the cement plants, it is in the two forms. One is the flue gases, again bifurcated between preheater and cooler, and the third and unexplored part of waste heat is the radiation losses through kiln. In the chart that is prepared based on the data made available by the plants, we can the losses from the kiln shell, they are as high as 8% in some of the plants. So that is actually attracting our attention that is there any methodology that we can recover the losses from the radiation heat from the kiln shell and utilize in some other purposes. So this is a schematic diagram for heat recovery from rotary kiln shell. So as we know that across the length of rotary kiln, there is a variation of shell temperature. So at the place of burning zone where we find the maximum temperature for kiln shell, so two plates they can be put at some distance from the kiln shell, and inside the plate there are some tubes in which fluid is flowing. So that fluid is evaporated, that fluid gains heat from the radiation heat from the shell, and that can be used either from either to the power plant where low pressure steam uses, we can use that, or we can use that in chiller operations based on the heat that is made available after the recovery of radiation losses. This is a real picture of one of the plant that is in Karnataka, where the plant, it has placed some tubes below the kiln shell, and the water that is being flowed inside the tubes, that gets heat, and that hot water is routed to the power plant for increasing the efficiency of captive power plants. So that is means not in the lab stage. Even some of the plants, they are coming forward to make recovery of kiln radiation losses. This is a concept setup drawing for recovering the heat from the kiln shell and routing it towards a dryer. So these are the routes where we are taking the heat from the sources and routing it to the dryer-like concept. There are many additives that are being used in cement plants that actually requires removal of moisture before putting them into the process. So I like to mention one of the prominent material, that is phosphogypsum. In India, there is an annual utilization of gypsum by 11 to 12 million tons. And out of that 11 to 12 million tons, 6 million tons of gypsum is being imported, because we don't have gypsum replacements that we can replace the mineral gypsum, so we are dependent on the import. So one of the promisable material is phosphogypsum. And why we can't use phosphogypsum? Because it contains 2 molecules of water. By the presence of those water molecules, there are some water-soluble impurities that are actually hindering, that are actually affecting the setting time of the cement. If by any process we are successful to remove the water molecule from that phosphogypsum, it is a very better replacement for the mineral gypsum. Even it is having 85 to 90% of purity. So if we use coal or other medium to making available the heat and removing the moisture, some renewable sources or some waste heat recovery sources can be used for evaporation of water from the phosphogypsum. So this is one of the possible schematic diagram. This is the uses for waste heat recovery to preheat the kiln feed. So we can make an arrangement in the preheater cyclone configuration where some portion of kiln feed, the temperature, it can be risen by the use of flue gases. This is another use for waste heat recovery. Actually, for cement plants, we all are trying to increase our thermal substitution rate. Up to 5 to 6%, we don't see any problem. But when we are trying to increase the TSR percentage from to 5 to 6%, so there are limitation by the system design. There are limitation by the compatibility. There might be issues of consistency in the fuel heat quality. There are differences of the physical properties for the mix that we are using as alternative fuel in the cement plants. So one property, one phase of material that is having consistent quality of heat and physical property is gas. So if we convert alternative fuel, solid fuel into synthetic gas, so that may be a promisable option to increase the TSR in cement plants. So this is for that only. So here we are using a gasifier type arrangement, and we are providing heat to the feedstock. So ultimately, the synthetic gas that is being generated from the gasifier, it can be used in the cement plants. And it becomes more useful in case of white cement plant, because there is a color is a main issue for white cement plant. So if we are using synthetic gas in white cement plants, so there we can see higher TSR in the white cement plant. This is a possible arrangement of generating synthetic gas and using into the plant. This is a use of waste heat recovery as a parallel system to the captive power plant, where we can increase the efficiency of the captive power plant. This is a waste heat recovery system integration with the AF dryer, because moisture is most of the time is a hindrance that we are unable to increase the TSR. So this arrangements can be thought upon for removal the moisture from alternative fuel. In foreign countries, actually we see a similar type of arrangement, but in horizontal way. That is known as Stella dryer. But in cement plants, there are a limitation of the space. So this vertical type of arrangement can be think upon, so that we can remove the moisture from the alternative fuel and use it into the cement plant. Here in the vertical system, from the top, there is a flow of refuse derived fuel having high moisture, and from the bottom, there is a flow of flue gases in upward motion. That is actually coming into the contact of alternative fuel through perforated plates. So these were the possible other non-power uses of waste heat recovery. So this is, I'm ending my presentation with the messages from the visionary, none other than late Dr. APJ Abdul Kalam, that what is the importance of energy we can see upon here. Thank you very much.
Thank you, sir. Now the next presentation is on the efficient hydrojet cleaning system for effective working of WHRS, presented by Mr. Nitish Pathak, New Tech, Faridabad. So I would like to invite Mr. Nitish Pathak on stage to give presentation.
Hello, a very good afternoon on the behalf of New Tech Group, Faridabad. Namaskar and thanks to NCCBM, BE and ASK to provide me this opportunity to present here. Next slide. Is it working? Next slide, next slide. Okay, fine. Okay, it's okay. So we are here in India since 1984 and having manufacturing sales, and we are also in contract services because hydrogen jetting system is a capital equipment. It's costly. So we are providing our services to more than 200 customers, you can say 200 groups in India and abroad also. We have 4 verticals. In manufacturing sales, we have new tech jetting equipment, that is high pressure, ultra high pressure, and low high pressure jetting equipments, manufacturing. And other is Partech. It's a smart cleaning system. We are the first in India who introduced the mechanized cleaning. We have the contract services, tenders in Delhi Metro, Rajdhani, Shatabdi. We have took care the cleaning and sanitization process of the first COVID wave in Pan India, and deputed more than 25,000 of employees. When everybody was in the house, we were working. So we handled the dead bodies and everything. The flight were open for us. I'm proud to be the part of New Tech Group. Now, again, that is Dustbuster. This is the renowned, very famous brand for the housekeeping equipment consumables manufacturing. In contract services, we have New Tech Eco Clean Limited is the limited concern of New Tech Group, and that is New Tech jetting equipment. Again, it is in contract services. These are our businesses in the 4 segments, and these are our 4 brands. That is Partech, New Tech, Dustbuster, and Devi. These are the services what we provide. Now, I am here for the New Tech jetting equipment, one of the vertical. We are in manufacturing, sales, and contract services. So this is the 5 commitment to our customer. Basically, I want to draw your attention that we do not take the water jet cleaning as a part of the process industry. We think that it is allied services. But you know, without hydrojetting in sugar industry, not a single bag of sugar can be produced. We are working there for 7 months. So why not we can use the water as a efficient tool. All the life originated from water. More than 17% water in our body. The water jet cutting is means evolving for the sheet metal cutting. So why not we can use water in the cleaning system. These 5 commitments are minimum downtime, chemical-free cleaning, increase efficiency, overall cleaning means we can clean any corner. But just we have to design the hydrojetting system according to the requirement. Now the last is increase equipment life. If you are doing mechanical cleaning, this means you are reducing the life of the equipment, of the condenser tubes and any surface. You are hitting, you are using chemical, you are using brushes, and you are reducing the life. Sorry. Pardon. So in today's scenario, these are the 2 areas where the hydrojetting systems are getting used. One is in kiln and the other area is the preheater. wherever the scale take place or unwanted deposition, the water jet system getting used, but occasionally, not in process. So I'm here. We can explore any way so that how we can optimize and make a good water jetting system that can work effectively for in-process uses. So this is the manual technique of cleaning in preheater and the kiln. See a man handling the handgun, simple nozzle, and there may be any chances of accident, human losses, casualty. So why not we can customize it. These are the simple guns and nozzles. This is straight firing round jet nozzle, what everybody is using. Even though they are radial nozzles, but those are getting used in tube cleaning only. So we are here with a solution. We are launching these rotating nozzle first time in India. This is first time in India for any hydrojetting company or any processing plant. That is a radial fire rotating nozzle, and here you can see the rotating nozzle that is front firing. So you know what the case? There are only two types of nozzles right now using in India. It is round jet and fan jet. Fan jet means V shape, increasing the area, reducing the pressure in the impact. In round jet, this is you can say like point destruction. You can just fire on a single point and the cleaning will be done on that point only. So you have to take more time to clean. So when you are using rotating nozzle, what happens that there are 4 jets which are firing forward and they are rotating also. There is no any bearing. It's rotating on the technique known as levitation. So you can say between the 2 layers of the metal, there is a water flowing on the pressurized water flowing, and that is creating bearing. So when you are using round jet and fan rotating nozzle, this will provide you effect 1.8 times when adding the effects of the round jet and fan jet at the same time. So the whole range is going to be launched in next 2 months. This is the rotating nozzle, front firing. Okay. So we are the manufacturer of high pressure jet pump, as I am saying. So this is our unique technology where we are introducing 100 mm of stroke length. Means this is low RPM pump. It runs more than below 400 RPM so that it can run continuously for longer time. And it can be embedded itself with the system. And these type of systems already we are supplied to SMPs, steel manufacturing plant, where we need to descale the roll sheets. Means when they come out from the roll mills, they suddenly get oxidized, and the system has to eliminate the scale layer that is deposited above the sheet metal. So again it will get rolled, the scale will be embedded into. So this type of firing system are continuously using in the steel manufacturing plants. 100 mm stroke length is very tough to make us. We are working hard since last 2 years, and now we achieved. Okay. This is the automated system of the condenser tube cleaning. If we can clean the condenser automatically, why not we can customize a system, we can plan a machine so that we can use those things into the cement plant or processing unit wherever you want the hydrojetting system to be included. This we are making and we can supply. No human required nearby the jetting area. It can be remotely operated. And now this is hydraulic system we are going to make it digital. Means mechatronics we are going to use, and remotely you can use the system. Okay. So this is one of the tests what we did, the rotating nozzle, and this is the salt deposition on the pillars. Just check out how it is firing. This is PepsiCo. Here we are using hot water jet cleaning. Our machine are efficient. They can run 12 hours non-stop on superheated water, that is 150 degrees Celsius. The water should be clean. That is diesel operated machine behind, you can see there, and we are cleaning the panels. This is the barrel washer. Now you can check out the result. These are the grades. We had the challenge there not to damage the SDP material made grades and again clean them. They were using 8 tons of chemicals per month, but we are not using chemical. We are just cleaning by simple hydrojetting and using this fan jet nozzles. Again, I will come to this point, how you can increase this standoff distance to use the 100% effect and potential of the pump. This is a cleaning of the exchanger tubes. These suits are certified. We are using it in Reliance. This picture is from Reliance. We are serving Reliance since last 8 years, whole Reliance group. This is after and before image. How an efficient hydrojet cleaning system changes the situation. Now this is the one of the research you can say, or trial you can say. Better standoff, higher impact, faster cleaning. The standoff is the distance after which the potential of the jet get diminished. Here the standoff distance is 20 mm. So this is technology, how we increase this standoff. We have developed that type of machining process here in India. We invested more than 2.5 crores and we developed this type of nozzles, especially processing for these micro drills. Now here, this is the ordinary nozzle what are available in market. So you can clearly see the standoff distance. See, we have increased the laminarity. We have increased the laminar flow, and this is our patented technology. So this is the difference. This is the demo video, but unfortunately it is unable to run. Now, what happens when you use mechanical cutters and chemical to the metal? Your equipment just losing their life. This is what happens when you use rods. We have also the system how to clean the pipelines. This is the Rotomol USG system. We can clean 200 meter of the pipeline system, 6 inches to 2 meter dia in the single shot. If you can provide us an opening on each 200 meter. If you have any blockage in the sewage system or any pipeline, we can use it. In fact, we are using the system in Gale Pata. Since last, you can say 15 years. We have ARC. Again, this is multi-LAN system. We can clean 3 tubes at a time. We are increasing using mechatronics. We have the consultant from ITs and sugar industries and thermal power plants. They are in our board. and we are developing the system. Most probably in next 4 months, the prototype is ready, the trials are being on, and it will be available in market in next 4 months. This is our system, that is 2100 bar machine, especially for the power plants and the cement plant. We also manufacture the ultra high pressure machine for the stone cutting and blasting. Okay. So this is a little projection what we got from the website, this is the source, Central Energy Authority, where we got this data. This is the calculation. If we are using G8 grade of coal that have the unit heat rate that is 26 kilocalorie kilowatt hour, then we are for the per kilowatt of the energy we are using 0.53 kilogram of the coal. So I read many literature from the European countries that they have reduced this value from 2.4. Why not we can use it? There is a term that is TPM, it being used in the industries, automotive industry, that total productive maintenance. If we are maintaining our equipment very well, definitely we can increase, we can reduce the coal consumption by 7%. And of course, we are doing it in NTPC Tanda. They accepted that the coal consumption has been reduced by 2%. And this is the figure for the 100 megawatt plant. These are the collected from various sources, and this is average calculation. So 86 crores can be saved per annum for a 100 megawatt plant. Annual CO2 emission by 100 megawatt plant, that is 8 lakh, lump sum 8 lakh tons. It can also be reduced by 7%. By per ton consumption of the coal, grade 8, 1.6 times of the CO2 emission is getting done. It can be reduced. Again, this is the 10 points and 10 major factor you should consider the hydrogen cleaning. The first one is zero chemical load, time saving, thorough cleaning, versatility. We have the capability to modify the system according to your uses. We can customize the system according to you. Then minimum inventory, low operating cost, labor saving, environment friendly, that is EHS, as you know very well, people friendly and easy to manage. Just call us, we will manage everything. These are the clients, but we told you, these are only 30 here, but we have the more than 200 groups on the. So friends, this is all from here. Thank you very much. I think some of calls should come to me. Thank you.
Thank you, Pathak ji. Now we are entering to the last session of this seminar. In cement plants, management targets for the selection of best equipments. But sometimes the performance of those systems, those equipments are not as per the reference value, or they are not compatible with the process parameters. Even it can also be the case that the plant personals, they put some changes in the system and they make it more efficient. That is popularly known as Kaizen. So to honor such ideas, such changes that plant they have done for their facilities, we have kept this session. So first I invite the officials from Satna Cement Works to project the case studies for the improvement of waste heat recovery system in their plant. There is one more request to all the presenters that to honor the timeline of this seminar, you please try to finish your presentation in 15 minutes. Thank you. Thank you for your cooperation.
Good afternoon. Myself P.K. Dhara from Birla Corporation. Along with me, Mr. Abhay Kumar Verma, Mr. Raviraj Singh and Kapil Gupta. And in front of dais, Mr. Sharma, Atul Sharma, Saurabh Mishra and Saurabh Sharma. We are going to present some case study. Before that, I must congratulate to our team and before presenter, and giving our opportunity to BE, BEE, NCCBM and AKS University. This is our Birla Corporation Limited. This is the flagship company of the MP Birla Group, incorporated Birla Jute Manufacturing Company in the year 1999. It was Mr. Madhav Prasad Birla who gave the shape to it under his chairmanship. And sir. Sir, our main business is cement, that is around capacity 20 million ton, and other than that is jute and iron and steel casting. Next. This is our mission, vision and values. I would call Mr. Kapil Gupta for the next slides presentation.
Thank you, sir. Next slide, please. This is our plant overview. In our Birla Satna unit, we have two kilns. Our first kiln capacity is 4500 TPD and second kiln capacity is 5100 TPD. Each kiln have 7.5 megawatt rated capacity WHRS system. And here we have shown the boiler capacity, AQC and preheater boiler. Our plant is procured from the China. Here is the manufacturer of boiler and turbine. Next slide, please. This is our waste heat recovery design data at which flue gas temperature our preheater boiler, AQC boiler and superheater is being designed. And during monsoon season, our load is 4.49 megawatt and 4.36 megawatt, and during non-monsoon season it is 5.8 megawatt and 5.9 megawatt. The auxiliary power consumption is 358 kilowatt. Please next. So, what is the waste heat source in cement plant? The waste heat source in cement plant, which is recoverable waste heat, is cooler exhaust and preheater exhaust, and non-recoverable waste heat are radiation loss, clinker heat, and fuel and raw material moisture evaporation. Next, please. So, next is what is WHRS process? As we know, WHRS is based on our steam Rankine cycle, in which waste is coming from the cooler, mid-tap and preheater exhaust. Here we have shown our flow diagram also, in which you can see the heat comes from our cooler, mid-tap and preheater goes to our AQC boiler and PH boiler, and the steam goes to the turbine and generating electricity. Next, please. So what is the environmental impact, direct impact of waste heat recovery system? So first is the dust load reduction. why waste heat recovery, as we know, the waste heat coming from our cooler and preheater, it comes with a lot of dust, which is collected in our cyclones and boilers, which is again used in our cement plant. And another impact is in gas volume. Due to reduction in gas volume and temperature, our fan power is also reduced, and our ESP and VDC efficiency also improved. Next, please. Previous. This is our AQC boiler flow diagram, in which you can see there are two tappings from cooler. The first tapping is ST tapping, which goes to our superheater, which directly goes to ST cyclone, then goes to the superheater. Second tapping is empty tapping, which goes to the AQC boiler through empty cyclone. And further, the low temperature gases goes to the atmosphere through ESP. Next, please. Next. This is our pH boiler flow diagram, in which preheater exhaust gases goes to our pH boiler, and remaining heat is used for our drying purpose in coal mill and raw mill, and low temperature gases again goes to the atmosphere through ESP. Next, please. So what are the advantages of waste heat recovery system? So advantage is, first is high energy efficiency. As the gas volume is reduced, it improves the power consumption of fan and improve the efficiency of ESP. Second is enhanced plant economics. That means, as we know, the waste heat recovery power is a less cost power, so the production cost is also reduced. Third is, it is a reliable source of power. It is totally depend on the kiln, so it is a reliable source. Fourth is the reduced CO2 emission. As we know, when we generate 1 unit from coal waste thermal power plant, it generates the 1.06 kg CO2 in the atmosphere. This is our approximate figure. So fifth one is, it generates green power without burning any fossil fuel. The fifth one, it meets our 24% power requirement of our cement plant. Next, please. So now I request my colleague Mr. Raviraj Singh to explain some case studies of WHRS.
Thank you, Kapil. Now we are going to present here some case studies which we have faced during operation of the plant, which are as under. Number one case study is choking of steam superheater. It was observed that superheater tube bundle was getting choked in every couple of months during operation due to compact design of superheater tubes, and sometimes due to heavy dust concentration in flue gas whenever kiln get disturbed or dusty. And it needs cleaning whenever we got opportunity during kiln stoppage or force stoppage of the plant. To overcome this problem, we installed a long retractable soot blower as shown in figure in superheater and operated it as per requirement once or twice in a week. By provision of soot blower, now we are able to do online cleaning of superheater while the kiln is in operation, and we have eliminated WHRS stoppage on account of jamming as well as generation reduction loss on account of jamming. Our next problem is deaerator water level and temperature issue. Actually, deaerator water level could not maintain to feed water in both drum of AQC and SP boiler simultaneously whenever load went above 5 megawatt. Actually, hot water return flow was getting restricted in deaerator head, resulting excessive use of makeup water of 58 degree Celsius directly from drain tank to deaerator, which reduced the temperature of deaerator to 100 to 101 degree Celsius. To overcome the problem, we dismantled the deaerator head and found that mesh strainer inside the deaerator head is made of MS metallurgy and was fully corroded and choked. We replaced the MS metallurgy mesh strainer with SS metallurgy. After this modification, restriction in feed water flow eliminated and deaerator water level being maintained normally, with designed water temperature of 105 to 110 degrees Celsius. This is the flow diagram of deaerator and water piping. We found the problem in deaerator head area, corroded mess, and attended it accordingly. Our next case study is automation of hot well level. During commissioning of plant, we had to control hot well level manually. We have to kept one person in each shift to operate manual control valve. As a remedial action, we installed variable frequency drive to regulate the RPM of condensate extraction pump. And after installation of VFD, now CPs are running with VFD and condenser hot well level being maintained well in auto mode, as well as manual intervention eliminated. Next slide will be explained by our Verma sir.
Thank you, Raviraj. If we talk about reduction in carbon footprint, here we are showing the saving we have made. About 8.63 lakhs tons of CO2 emission reduced till now on account of electricity generated through waste heat recovery power generation. As 1 unit of power emits approximate 1.06 kg of CO2 through coal-based power plant. Next. Here we are showing some energy saving projects taken in WHRS system. First, replacement of our TG Hall PNV system blowers with energy efficient fans in both the units. Second one, installation of VFD in CW pump of cooling towers in both units. And third one, replacement of trap water pump motor with VFD in both units. And actual power saving are showing here. Annual power saving 1.4 lakhs unit in PNV system, circulating water pump 5.9 lakhs and 0.8 lakhs against trap water pump per annum. Next. That it is the end of our presentation. Thank you.
Thank you, Team Satna, for showcasing very good case studies and also relating to the ultimate goal, that is reducing carbon footprint. And now in the series, I invite the team of Prisms Johnson Limited to present the case studies for their plant.
Good afternoon. I think everybody is stressed up. So I would say a few things. First of all, that I, along with Girish Singh sir, Rajeshwar Mishra ji, and my colleague Shiv Shankar Dwivedi, presenting Prism Johnson Limited for the waste heat recovery, innovation and sustainability. Just a glimpse in this. We are on an auspicious day when a day back we had celebrated a birthday of our engineer, Mr. M. Vishweswaraya. And after this, we are going to celebrate Vishkarma Puja. So I think we are on a very good day when we can talk of this innovation. So I should say we should applaud that on this such a good day, AKS, BEE and NCCBM had organized such a good thing to boost us up to make something good, innovative in WHRS. So coming back to the slides, we had done something in our WHRS before the installation. So I would like to show it to you. So first of all, the company profile. What we are. We are in a cement business and we are having a head office at our Mumbai. It's a Rajan Reja group. So you must have heard of. I will not go deep into that. So we are having a 5.6 MTPA manufacturing facility at Satna only, and 2 kilns are there. So I will show you too when it has been commissioned. These are 2 kilns which has been commissioned. First was commissioned on 1997 and second is on 2011. So what's the innovation in a WHRS? First of all, by looking to the Sankey drawing, you can see what we are generating and how much potential we have. 18% of the potential is there for WHRS generation. You can see to that in the drawing. I think it is not visible. But there I think it is 18% is written. So that is the potential which we can have in a cement plant. So what we had done, we are having 3 cycles. One is Rankine cycle, another is an organic cycle, and a third one is Cassiner cycle. So Cassiner cycle, yes, I can say it's a risky cycle and we can't adopt that. So what we had done, we had gone for a Rankine cycle. So what a Rankine cycle is? Why I am showing all these things? Because we are having a students sitting over here so that they can have a good interaction. Why we are discussing this WHRS over here? Because power plant had adopted all these things and now cement is also adopting these things in the aisle. So we are having 126 degrees centigrade which is pumped to 21 kg centigrade, 21 kg per centimeter square, and we had taken up to 425 degree at 11 kg pressure. So whenever it's come down, it come to 0.2 atta at the rate 60.7 degrees centigrade. But we had designed ACC. I will come back to the slide, latest slides which I can show you. So what's the tapping points in a cement plant? These are the tapping points. I don't have to give any lecture on this because many of them has shown why. A third thing is also there which is being used in, I think, Gujarat Siddhi Cement. That is the inlet of the cyclone, means inlet of the kiln. Because they are having some metallurgy problem is there, they have to remove from there. So they had installed a third boiler over there. So I don't go into detail of that. This is our matrix. How we had achieved this much of the heat we had taken, and this is the design thing which we had adopted, 17.7 megawatt and 4,25,000. Ladies and gentlemen, I would like to say you that we had hit a target of 4,80,000 in a day by this only. Why? Why this has happened? I can show you. This is the normal flow diagram in a cement plant. So just for a visionary effect, I had shown it to you. What we had done in the boiler, we had taken the consideration that it should be a vertical boiler with a horizontal tubes. AQC tubes are fin type and PH tubes are bare. MOC is SA210 grade A1. Why? Because it is having up to a limitation of 400 degrees centigrade. Above that, you have to go for 211. So that is why in the FSH, in the final superheater, we had taken 2 stages of superheater, and in that we had used T11 material. And it is a S-shaped of coil. You can see whenever the flue gas passes through this, what will happen? The bend will also absorb the heat.
We are here to see what is the potential we are having and how to get maximum of that. So these things we had done in our project. Now coming to the air-cooled condenser. What we did, instead of a water-cooled condenser, we had installed a air-cooled condenser, which has saved 2000 KLD water per day. And we had taken the biggest WHRS. You had seen that 17.7 megawatt, but the turbine capacity is 22.44 megawatt. A 10% PWA we had taken, as per our calculations. So we had designed the ACC with surface area which was comprising of 6 fans. We had adapted for 8 fans. And this is a oblong tube. Means we had not taken a single pipes, we had taken a oblong tube with a serpentine coils in that. Aluminum serpentine fills on that. So what we did point to water at the rate 45 degree. We had asked for 55 degree because Satna is a very hot zone. Whenever, you must be aware that whenever a vacuum is dropped, the generation effects, it is a very less effect, but for a thing like WHRS, you should have every loss is a loss. So, means we had seen that 0.2 megawatt reduces whenever a vacuum decreases there. And last and not the least, we had taken this turbine and vetted by IISc Bangalore. We had unbound Triveni engineers, Triveni turbine, to innovate and make a turbine for us, consulting IISc Bangalore. So that is why our turbine machine, it is okay, it is a 22.5 megawatt, but its base is of 40 megawatt. Why? Because the condensate heat quantity has increased. So what are the things we had done? I had shown it on the screen. You can see to that. All the thermodynamics we had done. Last stage blade we had made it of a different metal so that whenever there is a temperature increase or decrease, the last stage blade should not go by. We are having a 13-stage blade, a 13-stage turbine is with us, and we had taken HP injection along with LP injection. And it is an impulse reaction turbine. So that is why all these things, computational modeling of full scale has been done. Now in DM plant, there is one more innovation in the DM plant. What we did, initially our vendor, he was saying that is 5 M cube, it is sufficient. We said no, we want 10 M cube. Okay, that has been compromised in 8 M cube. So, but what we did, we installed SBA and SBC. And again another polishing unit so that the water quality should be consistent. It is not required, but still we had adopted a SBA and SBC, that is the strong basic anion, strong basic cation, along with MB. Because MB can solve that problem, but we had installed a SBC and SBA. All the CBD, whatever the boiler, I think everybody must be knowing that CBD and IBD, whatever we are giving, it is going to the end pit. We didn't taken it to end pit. We had fed it to cooling tower. By taking some time, means the temperature should come down, then we'll take it to the cooling tower. This is also a innovative idea by which we are saving precious water. See, these are the steps which he had taken for the green revolution. After WHRS installation, we had taken renewable sources had been increased, 34.2 of our total energy consumption has been increased from renewable energy, and you can see the scope 2 GHG emission that has gone down. That has gone down to around 37% from 2019 to 22. Now, using of green energy, you can see in the 21-22 financial year, we had drastically increased the green energy from our WHRS also. You economics people will say it's an inflation. So it's not like that. It's an innovation which had come down to some fruitful results. Now, this is a major slide which I would like to say. Initially in cooler and in preheater, anywhere we are using, for quenching that heat, we were using water. And every cement plant person do. So after installing the WHRS, there is a big reduction of 71.94% reduction of raw water usage in cement plant. So it's a big achievement. So this is our WHRS compact mini, and it is installed at the side of cement plant, and it is not hindering anything to anybody. But I would say it is a green power. Now, these are some of our achievements which we had achieved. Like CPP generating, if a CPP is there instead of WHRS, we had saved the 48.58 mkcal of heat, which will incur 12 ton per hour at the rate 4,000 GCV is saved. That is being saved. And while not emitting this much amount of heat, we had saved environment also. Reduction is GHG emission, which I had told you, 37.28, and WHRS generating cost is around 1.1, rupees 1.1 per unit. In turn, will reduce the cement manufacturing cost. Auxiliary consumption, you would be surprised that as per approved data and whatever we had approved, it is 8.5 as per vendor, Thyssen Group, they had told. But we had achieved 5.1% since COD. And I told you that we had decreased 71.94% of raw water consumption. WHRS designed on 28.32 kilowatt hour per ton of clinker, but now we are achieving 30 kilowatt hour per ton of clinker, which is okay, we will achieve that. We will again crossfire that. We will break this barrier also due to some problems in our shutdowns and all. That is why this has not been achieved. WHRS deemed availability in our plant is 98.39% due to high MTBF and low MTTR. And PGL works on zero liquid discharge. So whatever the water is coming from DM plant, from anywhere, we are utilizing it in our internal plant usage, in the power machines, in somewhere else. So we are using in that. Now, innovation and sustainability, I was telling, we had been awarded for innovation and sustainability, ladies and gentlemen. So, this was in the last year which we had awarded. Consequently, we had taken the award of Cement Plant of the Year also for this reason. So now, a very question which Sir was also telling, and they had made a substantial change for subsidies for WHRS. There is a glitch in for why WHRS is not being said as a renewable source of energy. Many of the things I had noted down over here for your only for your reference, because he had told everything, Mittal Saab has given everything, so I will not say anything on that. So I think my work has been done. Thanks a lot, sir.
Hats off to the efforts put by Prince Johnson Cement, and such efforts, such out-of-the-box ideas make management proud. I am just recalling the statement given by ED sir, ED Prince Johnson Limited, that 40% of power is being met through WHRS and renewables. Okay. So thank you, Prince Cement. So now I'm inviting Ultratech Cement Bela for their presentation.
Good afternoon, friends. फ्रेंड्स, आप लोगों ने सुबह से काफ़ी एग्जॉस्टेड लोगों का प्रेजेंटेशन देखा। अब तक तो आप समझ गए होंगे कि WHRS क्यों ज़रूरी है सीमेंट प्लांट के लिए। हम लोगों बेला में WHRS अभी 1.5 साल हुआ लगा है, तो मोटा मोटा चीज़ें मैं आपको बता देना चाहूँगा कि WHRS लगने से पहले और लगने के बाद पर बैग ऑफ सीमेंट कॉस्ट में 5 रुपये की कमी आ जाती है। आप आराम से चलाइए बिना किसी टेंशन के WHRS, बिना एफिशिएंसी के मद्देनज़र आपको 5 रुपया जो है किसी भी हालत में पर बैग की सेविंग मिलेगी और 3 से 4 साल में आपको पेबैक मिल जाएगा। इसलिए WHRS आज के सिनेरियो में जो फ्यूल कॉस्ट बढ़ रहा है, पावर कॉस्ट बढ़ रहा है, इस समय एकदम मस्ट हो गया है। यदि किसी सीमेंट प्लांट को सरवाइव करना है तो उन्हें WHRS लगाना ही पड़ेगा। मार्केट में बने रहना है तो WHRS लगाना ही पड़ेगा। और कार्बन फुटप्रिंट में यदि 10 मेगावाट का आपका है तो 400 टन पर डे कार्बन का आपका जो है सेविंग हो जाएगा कार्बन एमिशन में। मैंने कोई बहुत बड़ा प्रेजेंटेशन नहीं तैयार किया है, कोई मार्केटिंग नहीं करनी है मुझे। मैंने सिर्फ एक अपनी प्रॉब्लम्स जो हमारे सामने आ रही थी उस पर एक टेक्निकल लिटरेचर दिया था जनरल के लिए। इन लोगों ने कहा था कि कॉलेज जनरल में छपना है तो उसके लिए बनाया था। हम लोगों के यहाँ जो मिड टैप टेम्परेचर है, मिड टैप टेम्परेचर का आप लोगों ने काफ़ी जगह जिक्र सुना होगा। मिड टैप टेम्परेचर से हम लोग को AQC बॉयलर के अंदर हीट जाता है। जो मोटे मोटा आप समझिए कि WHRS में आपको टेम्परेचर चाहिए और क्वांटिटी ऑफ गैस चाहिए। यदि दोनों में से कोई भी कम बेसी होगा तो आपका जनरेशन इफेक्टेड होता है। और क्वांटिटी ऑफ गैसेस को आप हम लोग बॉयलर के अंदर जब आता है तो उससे हमको DP मिलता है, डिफरेंशियल प्रेशर। उससे हम मेजर करते हैं कि हमारा DP कितना है, डिज़ाइन से DP कम है कि ज़्यादा है, उससे हमारा जनरेशन लॉस होता है। यदि हमारा DP 20 mmWC कम होता है तो रफली 1.5 मेगावाट लोड हमको कम करना पड़ता है अपने प्रेशर और टेम्परेचर को मेंटेन करने के लिए। तो हमारा मिड टैप टेम्परेचर जब वेरी करता है, जब भी किलन डिस्टर्ब होती है, मिड टैप टेम्परेचर जब भी हमारा डिस्टर्ब होता है, तो टेम्परेचर कम होने की वजह से हमको जो है बाईपास डैम्पर, थोड़ा ऊपर कीजिएगा, स्लाइड थोड़ा ऊपर कीजिए। थ्योरी ऐसे कुछ खास नहीं है, आगे बढ़ाइए। हाँ, यहीं पर रुकिए। ये मिड टैप टेम्परेचर से हमने लिया है, और यदि हमारा टेम्परेचर कम होता है तो उसकी वजह एक हम लोगों को मिली है कि एंड टैप में जहाँ से क्लिंकर डिस्चार्ज होता है, वहाँ पे भी जो कूलिंग होता है वो एयर इस सब में मिक्सिंग हो जाती है, और मिक्सिंग होने की वजह से टेम्परेचर कम हो जाता है। तो इसके लिए हम लोगों का एक बाईपास डैम्पर दिया हुआ है। बाईपास डैम्पर जो 3 मीटर का लंबा चौड़ाई जिसका डायमीटर है, तो उसको जब हम ऑपरेट करते थे इसको बाईपास करने के लिए ठंडे एयर को, तो उस समय हमारा टेम्परेचर तो बढ़ जाता था लेकिन डीपी कम हो जाता था, जिसका मतलब है कि हमारा फ्लू गैस क्वांटिटी कम हो जाती थी और हमारा जनरेशन 1.5 मेगावाट के करीब घट जाता था। तो इसको काउंटर करने के लिए बाईपास टू बाईपास एक डैम्पर आया जो उसका 1/3 साइज में था। उससे हमको काफ़ी फ़र्क पड़ा क्योंकि वॉल्यूम हमारा कम जाता था। लेकिन क्या है कि ये ऑपरेटर डिपेंडेंट हो गया, ऑपरेटर की मर्जी हुई तो ऑपरेट किया, नहीं मर्जी हुई तो नहीं किया। किसी ऑपरेटर ने किया, किसी ने नहीं किया, तो वो बड़ा दिक्कत कर रहा था। तो हम लोगों ने कहा कि इसको जो है इंडिपेंडेंट कर दिया जाए, और हम लोगों ने एक पीआईडी डिज़ाइन किया। पीआईडी में क्या है कि पीआईडी मिड टैप टेम्परेचर को ट्रैकिंग करता है। ट्रैकिंग करने के बाद वो डिसाइड करता है कि हमारा बाईपास टू बाईपास डैम्पर कितना खुलना है। एक स्थिति के बाद फिर वो डिसाइड करता है कि खुलने के बाद इसका मतलब ये है कि आपका जो लास्ट स्टेज में 3 फैन लगे हुए हैं उनका आरपीएम ज़्यादा है, क्योंकि उतना वॉल्यूम ऑफ एयर वो नहीं एब्जॉर्ब कर पा रहा, तो उनका आरपीएम वो कम करता है। पहले तो वो बाईपास डैम्पर खोलेगा, बाईपास टू बाईपास डैम्पर, उसके बाद कंट्रोल नहीं होगा टेम्परेचर, तो वो तीनों आरपीएम, फैन के आरपीएम को कम करेगा ताकि वॉल्यूम ऑफ एयर कम हो जाए। उसके बाद जो है जैसे ही वो टेम्परेचर बढ़ने लगेगा तो वो फिर से नॉर्मलाइज कर देगा। ये पीआईडी कंट्रोल काफ़ी कारगर रहा और इससे हम लोगों को 1.5 मेगावाट के करीब फ़ायदा मिला है। और हम लोग और भी आगे देख रहे हैं कि इसमें मिड टैप टेम्परेचर को बढ़ाने के लिए और क्या कर सकते हैं, क्योंकि AQC बॉयलर में हमारे यहाँ जो डिज़ाइन दिया हुआ है उसमें पीएच का जो स्टीम है वो मिक्सिंग हेडर में आता है AQC में, और AQC में मिक्सिंग होने के बाद सुपर हीट जो होता है वो AQC में होता है, और उसके बाद वो डायरेक्ट जाता है टरबाइन के अंदर। तो AQC हमारे लिए जो है काफ़ी इम्पॉर्टेंट है, और इसके लिए हम लोग काफ़ी और इम्प्रूवमेंट के लिए देख रहे हैं। 10 से 11 हम लोग का जो है अल्ट्राटेक में 13 मेगावाट का प्लांट है, जिसमें हम लोगों ने 12.5 तक अचीव कर लिया है जनरेशन। लेकिन इसको हम लोग डे बेसिस पे नहीं कर पाए हैं, इसको हम लोग आवर बेसिस पे अचीव किए हैं। इसको सस्टेनेबिलिटी के लिए हम लोग काम कर रहे हैं। टाइमिंग का कंसेंट है। थैंक यू वेरी मच।
धन्यवाद श्रीमान। आपने अपने कार्यस्थल में प्रणाली के उत्कृष्ट उदाहरण को सरल, सहज और सुगम भाषा में हमारे सामने प्रस्तुत किया। अब हम दिन की अंतिम वक्तव्य की ओर आगे बढ़ रहे हैं, और इसके लिए मैं आमंत्रित करता हूं RCCPL सतना को।
Good afternoon to all of you, seniors, colleagues from other plants, and myself Pankaj Paroha, and I'm here on behalf of RCCPL Mayhar, which is a fully subsidiary company of MP Birla Group. and I'm here with my team members, VK Gautam sir, Mr. Praveen Tiwari sir, Kumawat sir, Mr. Anuruddh Kaul, and Mr. Rajesh Sharma. So this is the view of our cement plant. Next slide. We have equipped it with one AQC boiler and two preheater. These are the pictures of our plant. Shubham? This is the introduction of our cement plant as well as the WHRS plant. Our cement plant design capacity is around 10,000 TPD clinker production, and presently we are running with 11,000 TPD, 1,000 TPD extra per day. And the total power consumption for cement plant is around 45 megawatt, and approximately 22.5% of power consumption being fulfilled by the WHRS department. The rated capacity of our plant, WHRS plants, is around 12.25 megawatt, but the PG test was carried out at 9.7 megawatt after commissioning, which is the plant with the plant load factor of around 78 to 79%. The basic reason behind this low power generation is low flue gas quantity from our preheater due to some unknowable reasons, and with respect to अपना जो भी designed है preheater का, उससे थोड़ा कम मिल रहा है flue gas quantity, जिस वजह से हमारा PG जो है वो 9.7 around 80% के PLF पे हुआ है. These are the design parameters of our waste heat recovery system. We have, as I already says, that we have one AQC boiler and two preheater. And the design parameters are the inlet hot gas air in AQC boiler is 2,04,000 Nm³ per hour. And in case of pH 1A and 1B, it is 3,25,000 Nm³ per hour. The inlet hot gas air temperature, it is 448 in AQC boiler, and preheater it is 288 degrees centigrade. Then we talked about the outlet air temperature, which is 100 degree in the AQC boiler and 190 in our both pH boilers. Rated steam flow in AQC boiler is 19.6, and in pH 1A it is 14.6 and 9 HP and LP, and same in the pH 1B boiler. The rated steam pressure is in our boiler is 18.5 in AQC and 20.7 and 5.0 HP LP in our pH boiler. Rated steam temperature is 430 in our AQC boiler, 250 and 200 respectively for HP and LP in our pH boiler. Next. So let's talk about the journey we have started in 2019 August. Our plant is commissioned in 2nd of August 19 only with AQC boiler, and the pH boiler was commissioned in 12 September and 24th September 2019. So our complete plant is in operational in September 19. So the performance guarantee test was conducted, and the guarantee test result was 9.6 megawatt with respect to the design generation of 12.25 megawatt, and the PLF was 78.3 something. So what we achieved maximum, as I already told, that the PG test was conducted in 78% of PLF. We have already run our plant with PLF of 80.20, which means the more than the PG test. In the January 22, we have highest monthly power net generation of around 68 lakhs unit in a month with PLF of 80.20, and the average load was 9.82 megawatt. This is the WHRS power generation data after commissioning of plant started from 2019-20 to current financial year. We have generated 312 lakhs of units in 2019, and in financial year 2020-21, we have generated the gross power of 651 against our budgeted power of 676 lakhs per units. In the next financial year, in 2021-22, we have generated 689.92 gross, 699.58 of actual gross power with budgeted of 689. It means we have generated the more power than the budgeted power. Our budgeted power was 689.22 and the actual gross power was 699.58. In the current financial year, 2020-23, our budgeted gross power target was 724.92 lakhs in this year, and we have already generated 259.35 lakhs of units till the month of August 2023. So now here we have discussed some improvements and innovations in our waste heat recovery plant. We have the first one is the elimination of convention control valve with VFD for CEP pump. We have CEP pumps in which the motor supplied with the conventional DOL starter. It is supplied with the normal DOL starter. And the day consumption for that motor is 1400 kilowatt. Recirculation control valve was final control element to maintain CST level. We have installed VFD for motor, and now VFD become final control element in in place of control valve. So to CST level by controlling the motor speed. The current day power consumption is 900, which was 1400 previously. It is now 900 kilowatt. There is a change in the consumption of 500 kilowatt per day. And the VFD payback period is only 1 year. We have payback of VFD in 1 year only. Next. This is one more innovation improvement in our newly commissioned plant, the replacement of steam ejector. As we already discussed that we have the less quantity of flue gas from preheater boiler, and the design working pressure of our boiler turbine is 18.1 kg centimeter per square. But the steam ejector जो supply किया गया है, it is designed on 18.1 centimeter square pressure, and the plant is commissioned with working pressure of 14 kg, which is 4 kg less than the design pressure. It is far below working pressure of the ejector, and most of the time steam pressure comes below 13 kg, which is the most unsuitable for steam ejector working because unstable and develops very low vacuum. At the time it produces below the vacuum of minus 0.79 kg centimeter lead to the recirculation load TG, reduction in the TG load. To avoid these difficulties, we have initiated for a low steam pressure ejector. We have procured and replaced it with 14.1 kg ejector. We replace 18.1 with 14.1. After modification, plant availability has improved by 60 minutes during plant abnormality or kiln trip. जब हमारा 18.1 का था ejector, अगर किलन में कुछ डिस्टरबेंस होता है या ट्रिप होता है तो एक 20 मिनट्स का ही विंडो मिलता था जो हम प्लांट बचा सकते, उसके बाद नहीं, बट ड्यू टू लो वैक्यूम. बट जब हमने ये मॉडिफिकेशन किया 14.1 का एजेक्टर हमने दिया, अभी वो बढ़ के टाइम 1 घंटे हो गया. होम लोड पे आने के बाद हम लोग 1 घंटे तक सर्वाइव कर लेते हैं. नेक्स्ट. This is one more improvement in our plant. The mist cooling system, installation of mist cooling system in our ACC fans. During the peak summer season, as we know that in peak summer season the temperature rises up to 40-45 degrees centigrade, the ambient temperature, and it to increase the cooling effect of ACC fan, which result is the low vacuum. mist cooling system was introduced, and the result of it, we would reduce 2-degree temperature in our ACC system, drop in temperature. Mist cooling system which resulted in the increase in the vacuum and the efficiency of plant also. We are using the soft water in that mist cooling system to avoid any choking in the nozzles of our mist cooling system. And a mist of water is spread through the test tubes, such reduces the temperature in the surrounding environment. It is also further leading to reduce the temperature of air entering in the fan. So ultimately the temperature reduces and it increases as in the vacuum of our plant. This is the power mix data of our organization, our deemed organization. The total power requirement 100%. We have fulfilled 22.8% of power requirement from our waste heat recovery system. We have got 72.2% from grid, and we have also installed solar and the capacity of 5%. The budgeted lakhs unit from this financial year till August, we have generated the budgeted was 285.4 from WHRS, and the cost per unit is 1.47. And in second line from grid, we have we need to take 905 lakhs of units from grid with cost of 7.69 rupees per unit. So this is our data. We have fulfilled 22.8% of our power requirement from waste heat recovery. So what is our plan, future plan for improvements and way forward? We need to improve in our power generation with available heat, whatever the available heat in our kiln side, as our cement plant is already running very efficiently. The steam, the specific heat consumption was 676 for our cement plant. We have already run in a very good manner. So we need to generate more energy from waste heat by some other changes, available heat and put off of kiln. Improvement in the vacuum of steam turbine, especially during summer seasons, and a reduction in the auxiliary power consumption by optimizing the plant operation. So this is all from here. Thank you.
Thank you, sir, for such an excellent presentation. Now, before opening forum for a question and answer session, I take this opportunity to honor the efforts made by all the presenters. So I request Dr. Harshvardhan, sir, Pro VC, AKS University, to honor the presenters with the memento. So first I request Shri Nitish Pathak from New Tech Faridabad. There was an online presentation by Ms. Sunita Abad. So on behalf of Madam Abad, I request Kandare sir to take the memento. I request team from Satna Cement Works. I request official from Prince Johnson Limited. Next, I request officials from Ultratech Cement Bela. I request official from RCCPL Satna. Officials from RCCPL Satna. Sorry, RCCPL Mayer. I correct myself. Okay, RCCPL Mayer District Satna. Since morning, I have collected 2 mementos for on behalf of other presenters, but I have earned memento for myself also. So I request sir to give memento to me. Yes, sir. Thank you, sir. Thank you so much, sir. So now I request audience for any question, if they want to ask from any presenter. Before we move to our feedback and last concluding session. Sir. Pathak, sir.
Hello. I would like to ask a question from KHT. They had given their details and everything. I would like to ask whether the burner can work in a higher temperature. Means they had taken the secondary air of around 45 degree ambient. So whether it can work in more than that. Because if we are going to inject a secondary air of higher temperature, that will help in decrease of kilowatt hour per, means whatever the 740 figure is, that can be decreased. So can it be done or not?
Hello, sorry for inconvenience. Mr. Balis has just gone out. The point is well noted. We will give answer to you. Thank you. Anybody has any question?
Thank you, Pathak ji. it was still with KHD. If you can ask and revert it to me, है ना? कि operating and installation cost for a 40 TPH clay calcination plant. It is bit, I mean, maybe confidential, but any rough figures? Huh? Operating the per day cost. I mean, that will be the operating cost, installation cost, na? Operating. Okay, fine. And again, the clay calcination depends upon the kaolin content. It should be minimum 40% for a good replacement. So in the places like this, because India has got very scarce quantity of kaolin, so in the places like Satna where you have got aluminum silicate, can calcination of that replace, I mean, the kaolin content clay? And ultimately that's what I want to ask. And next question is for KHD. If I mean ICAN, sorry, it's from ICAN. If Sandra is still here. Okay, fine. Thank you.
Yes, sir. Anyone has question? Please raise the hand.
Thanks to all delegates to spend time from his busiest schedule to grace the occasion. Thank you so much. ठीक है? किस गई?
फीडबैक सेशन है तो
वोट ऑफ थैंक्स देना है कि नहीं?
नहीं फीडबैक सेशन है
तो जाने लगे सर। तो भर दिया ना फॉर्म सबने, दे दी।
I request all to please sit down because still a session is remaining. That is a feedback and closing session.
Only for a minute.
Only for some time. So for the closing session, I invite Khandari sir, Shri Kalra sir, and Dr. Harshvardhan sir over the dais. Mic. One mic, please, over the dais.
Yeah.
Okay. So, in today's session, we have made our full efforts to complete this topic in all the aspects, whether it's a technology, whether it's a consultancy, whether it's case studies, and even if any information required for financing platform. So, one session was also organized for that purpose also. Still, I believe that there are some points that we should know that we can improve upon so that the coming functions, the coming seminars may be more fruitful. So for that, I appreciate your efforts and I request you to please provide your feedback.
So, dear colleagues, I'll request if you have any suggestions for the improvement of such type of events. This is the third event we are organizing at Satna, which is almost at the concluding time now. And the fourth event we have to organize at RTC Nimbara. Third one was really successful with the help of AKS University. Let us give a big clap to AKS University for their ground help. And if you have any suggestions for which we can work on that and we can implement for the fourth event, that will be helpful to us. Thank you.
In the meanwhile, I also welcome Dr. B.N. Mahapatra, DG NCCPM, and Professor G.C. Mishra, Director, AKS University, for joining the dignitaries over the dais for this feedback session. So, any point?
So you are inviting feedback from the audience?
Yes, sir. If anyone want to come here and share his feedback, then he is mostly invited.
Ankur, can you get the feedback from the industry-wise? Prism Cement, Ultratech Cement, etc.
Yeah, that's very good idea. So first I request from Prism Cement, team Prism Cement, about their views for today's seminar.
Hello. Yeah, first of all, I would congratulate AKS University to do such type of events, and which we had seen in metro cities, and that type of event we had seen in Satna. So it's a great achievement for AKS University, and I will personally applaud all the students who had given their work over here, making us comfortable. Thanks a lot to you all. Last and not the least, I would say that power industry is driven by Indian Boiler Regulatory. So I would suggest now IBR should be the part of it, so that more suggestions will come. Because we are thinking of cement plant perspective, we should think of power plant perspective also. Thanks a lot, sir. Thanks all the delegates on dais, sir. Thank you.
Thank you, sir. Your suggestion is well noted. Now, any suggestion from Satna Cement Works?
Thank you, sir. Must congratulate to AK University or BE and NCCBN to give our opportunity to make presentation about our WHRS system. And also many thanks to student who helps the whole things program to make fruitful. And I पर्सनली बोलना चाहता हूँ कि यहाँ पे आने से मेरे को बहुत पुराने मित्र जो है, हमारा सर जो कल्ला साहब है, वो प्रेसिडेंट था यहाँ पे, उनसे मुलाकात हुई, और यहाँ पे मिस्टर पाठक एंड असीम भट्टाचार्य जी, वो भी पुराने साथी थे. तो इस टाइप का प्रोग्राम सतना में होना एक अपना लिए बहुत बड़ी बात है. मैं बोल रहा था और ये भी बोलना चाहता हूँ कि कल्ला साहब मेरे को सवेरे ही बता रहा था कि इसको रिन्यूएबल एनर्जी को ग्रीन एनर्जी में कन्वर्टेड करने के लिए भी अप्लाई करेंगे. दैट इज़ वेरी मच इम्पोर्टेंट एंड थैंक यू फॉर ऑल दिस थिंग. ठीक है सर.
थैंक यू सर.
RCCPL.
Any feedback from KJS Cement? Is anybody there from KJS Cement?
No, I'm sorry. KJS has just left because they have to commission their cement mill, so they are not available. They excuse us.
Okay, sir. So now you request RCCPL Mayyar.
Yeah, we are requesting now to Reliance. Thank you.
Okay, sir.
Thank you for organizing such type of big event in a small city, Satna. Actually, such type of event we have attended in like Goa Delhi, but it is a big achievement and many our colleagues could have participated. Thank you for organizing team. And thank you for Kalraji especially.
Now we hand over to Bela.
Gautamji, it was not because Satna is a cluster. Cement plants are there. That is the reason Bureau of Energy Efficiency selected this cluster as area where we can go to the DCs and DCs can come together and learn from each other. We wanted to create a platform for that. Similarly, we are going to now Chittor district. RTC Nimbara will be doing such type of event there itself. Thank you.
अल्ट्राटेक बेला गुड आफ्टरनून। आज हम लोगों के प्लान की कमी लाइट अप करने वाले थे, लेकिन पाठक जी ने कहा कि नहीं आना है। पाठक जी हम लोगों के साथ हमारे 10 साल काम किए हैं, तो इनका रिक्वेस्ट था और सेमिनार के बारे में इन्होंने बताया, तो हम लोगों को लगा कि नहीं चलते हैं और यहाँ से अब जा करके हम लोग प्लान लाइट अप करेंगे। शट डाउन था, तो ये जो सेमिनार था काफ़ी अच्छा लगा। पाठक जी से भी काफ़ी दिनों बाद मुलाकात हुई। यूनिवर्सिटी भी पहली बार मैंने देखा आज यहाँ करके, नाम सुना था लेकिन AKS यूनिवर्सिटी में कभी आया नहीं था, तो आने का मौका मिला, सौभाग्य मिला। यहाँ के स्टूडेंट्स लोगों का जो समन्वय था लोगों के साथ, वो काफ़ी अच्छा लगा। और सबसे बड़ी चीज़ होती है जो सेमिनार में हम लोगों ने देखा कि इंटरेक्शन करने से कुछ ना कुछ तो हम लेकर के ही जाते हैं, इनडायरेक्ट या डायरेक्ट कुछ भी हो, कुछ ना कुछ हमारे पास जाता है जो हमें कभी न कभी किसी न किसी रूप में फ़ायदा करता है। इसलिए इस तरह के इवेंट्स जो है हमेशा फ़ायदेमंद होते हैं। इसलिए बिजी शेड्यूल होने के बावजूद भी हम सब लोग मैक्सिमम 4 लोग आए यहाँ पे पार्टिसिपेट करने के लिए, और AKS यूनिवर्सिटी और पाठक जी को धन्यवाद कि उन्होंने हम लोगों को बुलाया। थैंक यू
सर। वन थिंग और ऐड करूंगा NCBM से कि हमको शेल रेडिएशन से भी पावर जनरेशन पे आगे बढ़ना चाहिए।
Thank you, sir.
We have taken this point already, and we are discussing with the supplier how we can proceed further and how we can penetrate into the cement industry. There is one trial plant already there in Kadapa district. It is in Dalmia Cement. It is under stabilization. We are waiting for the result of that, and we are talking to the suppliers, and we want to include presentation of even that plant maybe in the next event.
Now we are handing over to JP Riva Cement, Babupur, please.
नमस्कार सर। सतना जैसे छोटे से इस सिटी में AKS यूनिवर्सिटी ने जो इतना ग्रांड यहाँ प्रोग्राम किया, हम बाबूपुर प्लांट की तरफ से उन सब का तहे दिल से शुक्रिया अदा करते हैं। और सबसे अच्छा जो यहाँ के स्टूडेंट्स और सभी सीनियर साहब लोगों ने जो एक हॉस्पिटलिटी दिया, ऐसा हमने अपने लाइफ में कहीं नहीं देखा है। थैंक यू वेरी मच।
Now recently within 3 months time, clinkerization is going to come in district Panna, that is Amanganj, JK. Now we are handing over this mic to them. Thank you.
Thank you, sir. First of all, I would like to thank AKS University as well as the BEE for organizing a very interactive seminar, and this is very beneficial for cement plant as well as the WHR. I want to add one thing. WHR, when we are talking about the WHR, specific power generation part of clinker, we should start from this parameter, so that we can judge where the cement plant and as well as the WHR values lie. So this is my suggestion, because it's indicate the number of parameter, or it's a benchmark of as per we are going for BEE, it's a benchmarking parameter. Thank you.
Now very soon 10,000 tons plant is going to come in district Katni. The place is called Kemur. We are handing over to them, ACC Kemur. Okay.
And our design is 48 specific power generation pattern of clinker. It is one of the, I think, latest and very highest generation plant.
So far is the 43 unit I understood from this CIA, 43 unit is the highest so far.
Recently, we are achieving 43 in a Mangrove plant, JK Cement Mangrove, and it's designed on 45. So we are struggling to achieve the 45, but in Panna we are designing 48. So definitely we achieved 90% utilization of the plant. Definitely.
Bhavya Cement is generating 45 unit, but that is because of their inefficiency.
710, 701. Yeah. Specific power, stage 6 stage. And cooler from IKN, pendulum type.
We should appreciate JK Cement. Already they have, before clinkerization, they have already installed WHRS in 2 places. So that is the achievement, the JK Cement, the attitude towards the waste heat recovery. Thank you. Now there was a question for KSG. The gentleman, Mr. Bali Singh, has come, so he can answer the question from someone has asked the question for KSG.
One question is of mine, just,
Yeah. I was asking from KHT, they are using burner. So whether there is possibility of the air which has been induced to the burner, secondary air, that the temperature can be increased. Means the ambient temperature you are taking from the blower, so whether it can be increased or not up to 110 degree or 120 degree.
Yeah, your question is well taken, sir. Earlier also this kind of trials has been done when particularly when single chiller burner were working. But that time the temperature were limited to 70 degrees or something. But introducing 120 degree, definitely it will short the flame. So if we control the flame length, definitely it can be injected. So far, no any work is done on this because of fear that flame will be shortened and it may harm the refractory. So it can be done, sir, but while taking care of flame length. Thanks, sir.
May I request that this question answer can be taken directly, because some of the people here has to go for the important work. I'm sorry, we have to conclude it in the time. Thank you.
This is Nitish Pathak from Faridabad. Actually, मेरा सजेशन है एक कि जब हम किसी सिस्टम में रह के काम करते हैं तो उसके प्रेशर को ही झेलने का जो हम प्रयास करते हैं कि किसी तरह उस प्रेशर को हम झेलें, सो आउट ऑफ द बॉक्स सोचने का इतना समय नहीं रहता है. जैसे सर ने एक वो किल्न से रेडिएशन की एनर्जी को कैसे हम रिकवर कर सकते हैं उसके बारे में बताया. सो माय सजेशन इज दैट कि जो इस सिस्टम से बाहर रह रहे हैं, जैसे एकेडमिया से जो लोग हैं, उनके रिसर्च पेपर्स को भी एटलीस्ट हमें यहाँ शो करना चाहिए एक दो, जिससे कि हमें आउट ऑफ द बॉक्स जाके कुछ समझने का मौका मिले. दिस इज माय सजेशन.
Thank you, Nitish ji.
Sir, if I can take only one. It is with the KHD. I mean, my question was, what is the operating cost for 40 TPH clay calcination plant? Just a rough idea. Okay, fine. Other thing is related to the areas of Satna because clays are ultimately aluminum silicate. So we don't have kaolin clays here, and that's very important for percentage kaolin for replacement of calcined clay. So if you have got other clays or just aluminum silicate, how far it can replace calcined clays in LC3? I mean, clay in the form of stone, aluminum silicate in the form of stone, in that case, it won't be able to replace. And that's in abundance in Satna areas and nearby. Thank you, sir. Thank you very much. And has ICANN come? Just one short.
Asimji, please close it. You can talk to ICANN or anyone directly, please.
Okay,
we have already requested you.
Okay, fine. Thank you.
Now after this feedback session, now it's time to hear from the dignitaries at the last guide for the day. So I request DG NCCBM Dr. B.N. Mahapatra.
We'll go there. Hello. We have also listened a lot of interaction between the industries and suppliers and the subjects, and the subject matter experts are already there. No doubt it is a good indication that people from the plant has come in Satna clusters. If this type of seminars continues, at least you can be free from your work and come to this type of seminar to interact. That is a good sign for you people also. And this type of seminar also inculcate more knowledges, and this is the most good platform for our suppliers and also industries to know and how to do the things in a positive spirit. Another thing is that this is the good interaction between the industries and AKS University students also. This is a good opportunity because AKS University having such a facility, at least they are satisfied that facility has been utilized. And so many experts have already seen the facility. At least the students witness what is happening in the industries. And also suggestion is coming from BE. We can include certain courses also in the course of studies. When the cement technology course is already there, they should also know something about the energy audit, what is USTT recovery. At least from the concept, they should be also it will be included in the course. So at least we are very happy for the presence today. And this is a joint activity by Bureau of Energy Efficiency, National Council of Cement Building Material, and AKS University took the interest to organize this seminar, and it is a grand success. The presence also till the last up to 6 or 5, the presence is already there. So I request Satna cluster and AKS University, and so to conduct so more also seminars like this, because new concept is already there about carbon sequestration, carbon storage, carbon capture, also will be updated for that. So if we start this thing, also definitely we will reach at a certain points. So thank you very much. And I continue, this type of course will continue in future also. Thank you to AKS University. And AKS University completely organizer, because there is a lots of efforts required to make it successful. When a seminar or conference becomes successful, the people from the different ends, starting from the security, up to the staffs, all the students are taking a pen to make it grand success. So our thanks to the organizer, AKS University, BC, Pro BC, and also the directors, all the faculties, and all the students also as well. Thank you very much.
A very good evening to all. On behalf of AKS University, the chairman, pro-vice chancellor, vice chancellor, directors, all my students, all faculty colleagues, we are glad that we are standing here to express the vote of thanks. A special thanks to the chief guest, Mr. Agnihotri, President Mr. Bhattacharya, and their team, and also the team from NCCBM, also the team from BE director has come here. We are giving them thanks for sparing their valuable time. And I would like to thanks to everyone involved in the success for this seminar, for the making it happen. Hope everyone has enjoyed the good time. Thank you very much.
So now with the permission of chair, I call it end of the day. Thank you for your participation. Thank you for coming here. Thank you for the dignitaries on the dais. I invite all the delegates for a high tea in nearby also, C11. It's C11. Please join us at C11 for a high tea.